Good evening. My name is Chris Moynitsky. I'm a member of the Fort Worth Astronomical Society, and today we will be doing a moon viewing party. It's a bit bright. It is still actually a little bit early. Daylight savings time kind of messes everything up, doesn't it? So it's still light out, and if I look at the moon, it is not quite directly overhead. So today we'll be primarily looking at the moon for about as much as we can before it passes over my roof. And we'll also be looking for the new nova in Cassiopeia. So a couple days ago, on the 18th, we had a Japanese amateur astronomer who found a brand new star in Cassiopeia. And this is it's believed to be a nova. So what a nova is, and I'm not sure about this one, but maybe we'll test it and find out. A nova is a new star, from the Latin for new. And primarily this means that it's a star that wasn't there before, but all of a sudden it appears. It's not really a new star. The star was always there. Something happened, that it increased its brightness over a very short period of time. And so what happens typically with a lot of nova is it's a binary system. And I'm sorry if you can hear the ice cream truck in the background. It's still a little bit early. It's about 15 till 8 or so. Yeah, it's a little bit early. So back to the nova. We'll just kind of ignore the ice cream truck. So what we think is going on is that this is probably a binary system where we have a larger, younger star that's being orbited by a white dwarf. So big star, white dwarf is going around it. The white dwarf is the core, the dead core of a basically burned out star, something like the size of our sun, maybe a little bit bigger. And that core is very, very dense. So there's still quite a bit of gravity there. As it orbits close in, it sucks off some of that hydrogen gas from the outer layers of its neighboring star. That hydrogen gas falls upon the surface of that white dwarf and it just kind of stays there. If enough of it lands on the surface, it gets compressed and compressed and compressed. And finally, if it achieves the temperature and pressure necessary for fusion, it explodes. Now, sometimes you can have recurring nova, so that the gas that lands on the white dwarf builds up, builds up, builds up, and then explodes. It goes back down to zero. Gas comes on, it builds up, builds up, builds up, and it explodes again. And now we have an airplane coming overhead too. We are back in Burleson in my backyard, and we are on a flight path for Spinks Airport on the other side of the highway there. So it is noticeably louder here than it is in Grandview. Okay, so with the airplane gone, we go back to Nova. What we see is a recurring pattern where the hydrogen builds up, explodes, hydrogen builds up, explodes, hydrogen builds up, explodes. Sometimes we have a one-time nova, so that the hydrogen builds up to the point where the explosion rips apart the white dwarf completely. There's nothing left after this. We don't know which one this is yet. So that's something that scientists are looking at, primarily through spectroscopy studies. If we can find it, we're going to go ahead and try to do some spectroscopy of it tonight and see if we can get a spectrum, see if we can get an image at least, get a spectrum of the star, see what we can see. All I can say is we will see what we can see. So that's that. Last night I got the telescope set up. Not the greatest setup that I've got, but it seemed to do pretty decently. So what you can see right now is the telescopes are set up. I have on the left-hand side, this is a TeleVue 101 apochromatic refractor, and on the right we have a Astrotech Ritchie Cretan 8-inch carbon scope. So what this is going to let us do is have a wide field view and a deeper field view. I'd actually hoped to drag out the club's 11-inch Schmidt-Cassegrain. It's a big, heavy scope, and I just didn't have the energy to drag it out last night. So last night I went ahead and just set it up and did a polar alignment, and that's as far as I got. So we are polar aligned. The telescope itself is not aligned yet. We're getting there, but it should be fine. So I've made some modifications. I've raised it up a little bit. It's a little bit easier to use than it was last time, 2 weeks ago. Hopefully, we'll be able to do a decent job of observing tonight. So here's what we got. We have the scope set up. I have cameras on both. I have both of them zeroed in. I have the all or the wide angle camera ready to go, except it's still too light. That's part of the problem. It's still too light. So that's what we're dealing with. If you have any questions, if you have any comments, suggestions, targets for tonight, if we're able to hit them here from the city, go ahead and put them in the chat. I will be monitoring it and seeing what's going on. I've got it off to one side, and we'll see what we can do. So first things first, telescope needs to be aligned. I can't align on anything right now except the moon, and I don't think it's going to let me align on the moon. The moon's one of those targets where it moves so much that most mounts will not let you do alignment. So what I'm doing right now, what I need to do is tell the mount what is it looking at. So the idea behind it is I have the mount polar aligned, so the axis is pointed towards Polaris, or just off of Polaris at the celestial North Pole. The mount has GPS built in. This is a Ioptron CEM 60 EC, so it knows where it is because it has built-in GPS. It knows pretty close to where it's pointed at because of the digital encoders, but it's not exactly accurate, and so I have to tell it, point at this star, point at this star, point at this star, and once it's aligned, once it knows, okay, now I'm supposed to be looking at this, now I'm supposed to be looking at this, it will figure the rest out. I hope. I really, really hope. We had issues with it last time. We'll see what we can do this time around. So it is now 5 till 8, roughly. And honestly, we could have waited a little bit longer. The only problem is the moon is in the first quarter. We did miss the lunar X, but it was during the middle of the day, so it was very, very difficult to see. The lunar X is a feature near the terminator of the moon. It just looks like an X, and you can only see it for a couple of hours close to the first quarter. For us, it was this afternoon, and it was pretty much done by about 7 p.m. And it was way too light at 7 p.m., so there's not really much to see. All right, so what do we got here? Got everything set up. Got the software running. I thought this was going to run. Nope, not yet. So let's do the best we can. That's all I can say. Let's just do the best we can, and we'll figure it out as we go. Got this going. I have all right, so let's do this. I'm going to switch back over. And now we're going to be looking back at the telescopes. So the webcam here has a little bit brighter view. It will hopefully let us see a little bit more, or let you see what I'm doing. So I'm dressed nice and warm because it is going to be a chilly night. I expect it to be down into the 40s. Not too happy about that, but it's better than the 30s or the 20s. So I have cameras on both of the telescopes. And if it's a little bit quiet, let me know. I can see if I can turn up the volume. Just put it in the chat. See, there's some chat going on right now. How much is this kind of telescope? We're doing prices now. Okay. It depends on the telescope. The telescope on the left, an apochromatic refractor. This one probably runs $2,500 to $3,000 brand new. The Ritchie Cretan astrograph runs about I think about 1,200 new. And then you have the DSLRs on there, and I've got the DSLRs, and I've got other astronomical cameras. I have a guide scope. I have everything here. The mount runs around, I think it's about 3.5 grand brand new. So it does tend to be expensive. You do not have to start off this way. You can actually start off with doing astrophotography on the regular DSLR that you have and a tripod. This is built way up, and this isn't even top of the line. You can get mounts for 15, 20, 50, $100,000 if you have the kind of money, if you have the kind of space. Really large telescopes require really large, very expensive mounts. So, all right, here's what I'm going to do. I've got the moon. It is past the meridian, and the meridian line, basically you run a line north-south, straight line, and then directly overhead it hits the zenith, and that's your meridian. So the telescope will only go up to the meridian and then has to do what's called a meridian flip, and then it goes over to the other direction and then tracks from there. So what we're going to do, everything is on, is go menu, going to go select and slew, solar system, we're not wanting that. We're going to see just how close we are. Got this around, and for anyone who's seen this before, last time I had a lot more weight on a shorter countershaft. I actually managed to get an extension. I've been waiting for this thing for like 6 months. It's taken that long to get through. Oh boy, it's not a good sound, is it? Yeah, I don't think it's quite right. Should be over here. Yeah, let's go ahead and get it. So I managed to get a countershaft extension, and that lets me use less weight by utilizing the leverage. So the shaft is, or the counterweight is way out without me having to add an additional weight right here. Advantages and disadvantages. The biggest advantage is I don't have to carry around a ton of weights. I don't need an extra weight here. I can just work with what I have, and this is absolutely perfect for what I need. So I'm gonna point this at the moon. Let's see what we can get. And I managed to get my little flip mirror working. Here we go. So this is a finder. This is called a TeleVue. Oh shoot, Starfind. I think that's what it is. It has a little red LED. Has a piece of glass here that's at an angle, so I can see the red dot on the glass. And this little mirror keeps me from having to bend over. I zeroed this out earlier. That is close. So I'm going to try to get a little closer. One direction. Better direction. Better, better, better. That's about it. Now I'm going to switch over to my cameras. With the cameras, just say, okay, direction, better, 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 better. So all I'm doing right now is trying to center the moon and just say, hey, align to it. Then you sync to target, enter. Enter. It's synced. Cross our fingers and hope this works. Okay, first things first, I have to focus it. I have to focus it from here because I don't have remote focusing yet. All right, that's okay. Hey, that's not bad. Okay, next is, and all I'm doing is I'm zooming in on the image. Get the focus. Okay, that's pretty good. Pretty good right there. Okay, so, oops, hold on. Wrong button. Do this, and next I actually have to plug in my cables. And once I plug in my cables, we'll be able to watch it from the laptop, which is really what we want to do. Because it's kind of boring for you to see me do this without actually seeing the results. We're not going to be doing some good. That was close. We're not going to be doing something on little tiny screens and pointing a camera at a screen. That's just not any fun. Wrong. There it goes. All right. We'll swing this over. And I don't know how I'm going to have this here, but somehow I've got to get it. Okay, leave it at that. Gently step over. Okay, so right now it is pointed at the moon, and let's go ahead and do this. All right, here we go. What is this? This is a finder scope, so this is kind of what I want to see. It needs a little bit of focus, so let's just do that. Let's check out how good the focus is. It's not terribly good. I want to get a little bit better than that. Okay. And somebody coming over. So, hi. Came to look at the moon. Do you want to look at the moon? It's up above. Okay. Let me do this. All right, here we go.
I can't see it.
It's directly overhead. How can you not see it?
I can't see it.
There it is. It's right there. So this I'm going to be using as a guide scope, but we want to sharpen up just a tad. And we'll see. We just need to zoom way in. So this will be a little bit hard, but we'll figure this out. A little bit longer of an exposure. Get a tad bit brighter. That's what we want. It's a little bit too bright. Okay, gotta get a little bit sharper. How good we're gonna sharpen this, but trying. That's as good as we're gonna get it. And honestly, that one's probably going to be okay. Remember, this is a guide scope, so we're not going to be using this thing really for too much else other than guiding. But it gives me a nice little finder view, so we can hopefully see something. So here's what we got. It's pointed pretty close to the moon. That's not too bad. Switch to a different camera, and I have the all sky camera. Not really an all sky camera. I shouldn't say that. This is a wide view. So we're going to go to 100. Here we go. This is a very wide view. We're going to knock with that way down. So this is the moon right there. And I thought this was going to be centered, but apparently it's not. Mwah. You're going to go inside? It's kind of cold. You're going to be out here? Okay. So this view right here is pretty decent, but you can see that is a ½ degree right across there. So we want to be able to see quite a bit in this camera. It's going to be a, not exactly an all sky camera, but it's going to be a fairly wide angle camera. And it is starting to get a little bit chilly. Wind's blowing just a tad, but it's not too bad. All right, so let's do this. Let's go ahead and bring this up. I'm going to bring in T6i. That's what we want now. Hope this is synced. I hope this is tracking. And we're going to do planetary. There we go. That's pretty decent. Okay, so we got a shutter. Let's get that ISO way up there. There we go. That's probably better. 1600. All right, let's zoom in on that. We need to zoom in a lot more on that. You can see this is a fairly wide angle. We're seeing all of the moon. So this is a ½ degree across. The moon is a ½ degree. And the way you can think of it is you take your thumb, put it way out at the end, and what you see in the sky, that covering just your thumbnail right there, or the width of your thumb, unless you have gigantic thumbs. A normal sized thumb will give you a ½ degree across field of view. So that's kind of a good reference you can use, especially when you're just looking up at the sky and you're trying to figure out, well, how far is something away? Well, I know it's like 6 degrees. That's 12 thumbs. If it's 3 degrees, it's yeah, 6 thumbs. Um, and the yeah, you can use your hand. I forget what the hand measurement is. I want to say it's like 15. Is it 15 degrees? I want to say it's like 15 or so. Um, so you can use parts of your hand and parts of your body to kind of measure off distances in the sky in degrees. So we're looking here at the moon. Let's go ahead and zoom in. I'm going to zoom way in here. And again, this is a wide angle view. It's not terribly gray, but that's okay. Here's what I want to do. I'm going to go back to imaging because I'm going to take a quick image and we're going to play with it some. So I'm going to do 800. Let's see how long of an exposure. We want a pretty fast exposure. Let's just do 1,000. See what we got. Very fast exposure. Not doing anything special with it. Want to see what it looks like. There's a reason for this. I forgot. Let's kill that. I'm gonna go ahead and mute that sound because I don't need it. All right. That's pretty decent. That's pretty good. So we're not doing any super high resolution stuff yet, but that's okay. We can switch to those cameras later. I'll have to put it in and refocus. But for now, this isn't too bad. So what are we seeing? We're seeing right here along the terminator. Ooh, there's an X. Is that the Lunar X? I don't remember if that's Lunar X or not. I don't know if I've seen the Lunar X before. But we are looking at Mare. And what I want to do is this. I'm going to take a little bit longer of an exposure. So I'm looking at my histogram out here. And that's not too bad. But what I want is a little bit more. And actually what I want, yeah, I want this. So what I'm doing is I want a much longer exposure, and I want to bump up my, or drop my ISO down, I should say. Keep my ISO down, because I'm going to try to do, oh, that's already good, okay. What I'm going to try to do is bring this into Photoshop, and I want to check out my histogram. So my histogram's looking okay. You can't see my histogram. That's fine. That's still fine. I want to make sure that I've got nothing really blown out. That's kind of blown out. So we need a little bit. Let's go 200. Try that. And what I'm going to be doing is I want to show you the colors of the moon. If this works. If this works. So here we go. Let's see what that looks like. There we go. All right, where is this? Open file location. I've got a ton of old files in here. That's okay. Yeah, I should do it by date. Oh man, that's not too bad though. That's not too bad. It's just a lot of files. So what I'm thinking about is I'm going to drag one of these into Photoshop and we're going to play it in Photoshop so we can actually see the colors of the moon, which is kind of important. If I can just get to it, light. Okay, that's good. Open with Photoshop. See where to go. There it is. Okay, so I actually have multiple monitors here. So what you're seeing right now is just the view of the moon, and not Photoshop yet. So I'm waiting for Photoshop to load up. There we go. Camera raw. That's fine. We're going to open it up that way. That's a pretty view too. And I'm going to bring in Photoshop here. It's the easiest way of doing this. There we go. You know, if I'm going to keep doing this, I probably need a faster laptop. But that's all right. I don't typically do live editing like this, but it's fine. We're going to we're going to crop this down because we don't need everything. But I do want to look at the histogram. Window, histogram, histogram, histogram. Okay, that's not too bad. All right. Here's what we're going to do. First, I got to zoom in. This is pretty tiny. Let's get big. Oh yeah, we can see some detail. Now it is pixelated because this is a wide angle image. So even this is a 24 megapixel camera. This is not. Um, this just takes up a small part of the sensor, but that's okay because we're not really interested in seeing everything like that. Here's a one I show. We're gonna play with mode. We got that. Let's do curves. I just want to make sure my curves look okay. Yeah, that should be it. We don't want to overblow it. What we want is a little bit like this. And just by looking at it this way, we can already see this mare is different than this mare. This area up here is a different color. And we're going to do some, see if I remember how to do this, hue saturation. Yeah, we're going to do some hue saturation. So hue and saturation and lightness are just some ways of changing colors. We're not really going to be changing colors. We're going to be enhancing what we can see. So the enhancement is going to be this. I'm not going to change the hue. The hue changes the color balance of an image. What we want is to change the saturation. Because right now everything's kind of gray. We want to change it up a bit. Not really seeing that much of a difference. Everything's kind of blue because it's still not quite dark. Once it gets dark, it'll be a lot easier to see. Let's see what we do. Yeah, we don't color it. Yeah, we're not going to do that. There's another trick, and I thought I remembered what it is, but I don't think I do. So instead, we're going to leave this as it is. I'm going to do, let's do auto color, see what happens. Okay, we got that. It's more of what it is. Oh, I know what's going on. This isn't a true color image anyway because I have a filter on there. I put the filter on the camera. It's just fine. Worst case, I'll take it off again. But zooming in, we can see there's definitely color differences between the different mare. And right here, this is a fairly stark line right across there. And it's fairly visible for you guys. On my monitor here, it's not terribly great. On my side monitor, it'd be great for me to see, but you guys would be able to see this monitor. Multiple monitors are a really, really nice thing for a lot of us that we use. Especially like at work, you can have multiple things going on. It's just easier to keep track of everything across separate monitors. So what do we have? We have this definite difference in color. So what this tells me, first of all, is that you have different flows of magma that are coming up. So the mare are the result of impacts from large asteroids or planetesimals that impacted the surface of the moon during the Great Bombardment period, early bombardment period, I should say. They punched all the way through the crust, went into the mantle, and so the entire area was molten. It was upwelling of mantle material, and this is a basalt. So it's a darker rock than the lighter silicate stuff over here. So wherever I'm pointing to over in this area here, down in the lower right-hand corner, this is all silicates. Anything that's super bright is going to be a silicate. The equivalent on Earth, the silicates are the continents, and the mare would be the ocean floors. It's a denser, darker, heavier rock. Mare does mean sea in Latin, so people thought, well, these are dark spots on the moon, they must be oceans. And so, you have the Sea of Storms, the Sea of Tranquility. I can't remember anything else off the top of my head, but there we are. They thought these were oceans. They're not, but it's coincidentally the same material as the ocean. Oh, here we go. What do we have here? We've got a crater around the Terminator. There we go. That bright spot right there, we have a rebound mount. So when you have small craters and something impacts, or sorry, when you have a small object, something impacts Earth, Moon, whatever, it makes a small crater. You can just think of it as a little concave crater, cross section. Everyone's seen meteor crater. That is a small crater. Bigger craters melt the underlying material a lot. Just like a drop of water hitting a drop of water going to a glass of water. The surface gets disturbed, goes out, and then comes back in and makes a little peak. So the little droplet flies up and then it goes back down and keeps doing this for a bit. Um, on the moon, with molten rock, instead, as it comes together again, it just freezes. And so we have these central peaks in very large craters, and we just call them rebound mountains. And it's a big old mountain in the middle of a crater. That's all that it is. We only see them in very large craters. Okay, if you have any questions, if you have any comments, go ahead and put them in the chat, and I will be watching. All right, so we're still looking at the moon. I'm going to switch over to a different view. We're going to disconnect that camera. We're going to reconnect the other one. Oh, this works. Yay, there we go. So we're going to do planetary. Let's see what we can see. See if we're still dead on there or not. There we go. So this is an astronomical camera. It's a dedicated astronomical camera. It will go ahead and give us a much closer view, but this is going to be shifted towards the red. This camera is a lot more sensitive to infrared than most cameras, so, or a stock camera, but we can see, here we go, there's a rebound mountain right there, number of craters, there's a rebound mountain right over here too. So just all over the place here. This is actually kind of a nice view. I think we're going to need to have, I think we're going to have to put in a different camera. Yeah, especially if we want a better view. Definitely want to put in a different camera. So I'll have to switch it out. Nothing else to do, just switch it out. But in the meantime, let's go ahead and just take an image and see what it looks like. And this is the old image. So we're going to switch back to imaging. Let's do the same settings, see what happens. So quick exposure. This is a much larger camera, or sorry, it's a much larger telescope, 8-inch versus 4-inch. And it's deeper. This is, so it's an f8 versus f5.4. So it gives us a smaller field of view. Whoa, that's too much. Too much, too much, too much. Oh, because it's bulb. Of course, because it's bulb. What did we do? 200 last time? Let's do 400. As you can see, it's way overexposed. But we can see, hey, cool, we can see a little bit of the darker side. So we can see the edge of the moon right here, the edge of the moon right there. That's a little bit of albedo. This is light reflected from the Earth back onto the moon, back onto us. That's not bad. Focus looks pretty good. So if I was going to be doing this, I would be not using this camera first of all, but I would be using this telescope. I'd be taking multiple images and I'd be piecing them all together, just stacking them. You can see craters here. This is pretty good. And then we have a rebound mountain right there. We can see differences in color all through the mare. See, this white spot is probably a more recent crater. Zoom out, yeah. So when you see white spots typically indicate more recent activity, more recent impacts than something else. So for example, here we go. We have a crater right here, and we have rays coming off of it. You can see the rays, and rays are just patterns of ejecta. So it's stuff that was in that crater that just got blown out, and it just lands in a straight line. There's no wind on the moon, so it doesn't get blown in a certain direction. The way it comes out is the way it's going to land. It'll just keep going a little bit further out. And because the moon's gravity is a sixth of what the Earth's gravity is, it's the ejecta can travel quite a bit before coming back down. We have more spots here. The white spots is just more recent impacts. Here you can see that line again. It should be a little bit more obvious, I think. And again, we have this kind of a triangle here, different coloration than what's here. And it is definitely different coloration because this here is a smooth gradient. So you can see it's lighter here, it's going to dark as it comes closer to the terminator. But this does not follow that same pattern. So we've got these differences. Here we have more differences as well. You can actually see them pretty well. Here's a ray. Yep, here's a pattern. we have these rills. So these are cliffs on the moon. So that's pretty cool. All right. So I can do this. Let's go ahead and sharp cap. I want to see where this is. Yeah, this is a little bit off. So I'll be closer, but it's not. Um, so what can we do? That's not what I wanted. There we go. But at least this will tell us close to where we are. Remember, this is going to be wide field. So, and I'll show you in just a moment. Let's get longer exposure. Let's get a 5-second exposure almost. And I just want to see anything. Oh, 5 milliseconds. No, that's what I want. I want something longer. Here we go. I want 5 seconds. Here we go. So, lens flares. Nobody likes the lens flare, but that's okay. It's the moon. It's going to be bright. So we can see some of the stars just through here, which is absolutely fine. What else can we see right now? It's just the moon. All right. I think what we're going to do, it looks like a moon made of pink lemonade. It's kind of okay. So remember when you were a kid, the moon is made of green cheese, right? No one looks at the moon and thinks it's green. Green cheese is actually a phrase. I believe it's medieval. Sorry, medieval. Um, Green isn't the color of the cheese. Green means it's a fresh cheese. Nowadays we call them like farmer's cheese or like a ricotta or like a cottage cheese, a homemade cheese. You can make homemade cheese at home. All you need is warm milk and a little bit of vinegar or lemon juice, and warm it up and stir it, stir it, stir it. Break up the curds and run it through cheesecloth, and squeeze out all the whey, the liquid, and you got your curds left, and that is a green cheese. It is a fresh homemade cheese, and so people said the moon looks like a green cheese, a fresh cheese, a white cheese, not green as in the color, but green as in fresh. So there you go. Your little lesson for today. Um, let's do frame and focus or planetary. Let's do frame and focus because I want to make sure that we're still in the field of view. Yeah, that's pretty good. Okay, here's what I'm going to do. I'm going to switch out this camera for a different astronomical camera. I just have to find, where did I put my stuff? I had a flashlight. I think I left it inside the house, but that's okay. So what do I have? I have a this. I have a cable, something to keep me warm in just a bit. I have power cable. Okay, I can do this. I can do this. It should be fairly straightforward. So we'll go ahead and switch out to. Here we go. All right. So you can see it's still pointing at the moon, and it is actually getting chilly. So the temperature it was really nice today too. It's nice and warm. It's almost 80 degrees. It's pretty nice in the sun. And then pretty much as soon as the sun set, we're now down to 61 or so, and it's dropping fast. So fortunately, I do have something more to wear. Yeah, so let me dig up the other camera. Go, I hope everything's on here. We're gonna switch stuff out. Yeah. Ooh, no. Ooh. Oh, that's not good. Not great. Not bad. Okay. So right now we're doing this view. We definitely don't want that view. I don't care about that view, but y'all can't see that, which is fine. I'm gonna get that. And what I'm doing, I'm just gonna disconnect everything. Nope, I don't need to do that actually. There you go. all I did is I dropped down the, uh-oh, that's not good. Uh-oh, it's not good at all. Now I gotta think about what I'm gonna do. That should, oh boy, that should be enough. Okay, so what I'm doing is I'm putting on a field flattener on the camera. I'm plugging in power to the camera, and I'm digging up a USB cable. Camera, so just plug it in. This is up. Good. Sorry, it's a bit loud still. Power, speed. So fortunately, I do have power at the telescope now, which is nice. Very, very nice. Make sure the USB is in the right direction. Plug it into the hub. Okay. Excellent. So what that means is I have a camera that is on. Now the question is, can we see it? Yeah, we can see it. Okay, what are we looking at? Ooh. Yeah, that's not going to work. That's definitely not going to work. That's what we got. So we need to have a whole lot less. And right now, that's so out of, just out of focus. Let's get it up to about here. That's way too much now. 12 milliseconds. You think that's enough? You think that looks good? I think that should be fine. All right, can y'all see that? Yeah, that's totally out of focus. So here's what I'm going to do. I got to get it into focus. We're going to do that 100%. Yeah, so let's see. Let's see how well we can get the focus. Yep, wrong direction, I think. That's better. Better. Almost. That too far? There we go. Get there. Okay. So what are we looking at? We're looking at the edge. It's still not quite in focus. I think it's just still too super bright. Let's go ahead and get that down a bit. Yeah, it's still not quite in focus. Getting there. It's getting there. We're almost there. But wow, this is going to be a really close view. So I need to zoom in way a lot. We got to look at this crater here, and you can tell this crater is just way out of focus. Just, it is what it is. So what I have to do is, yeah, we're going to go ahead and go back, and we're going to have to refocus to get it a lot closer. So hang on just a moment. How much are we going to focus? Line focus, almost. Post. I just got past it. How was that? Now I gotta sit down again. I gotta see just how good that is. That's pretty decent. What do y'all think? I think it's gonna be pretty decent right there. All right. So we're gonna zoom back out to, this is what we're looking at. So let's fix it. Gonna move a bit slowly. Which direction? Wrong direction. That's what it is. It's always the wrong direction. Doesn't matter what button you press. It is always going to be in the wrong direction. Again, wrong direction. Every single time. It doesn't matter. It's always the wrong direction. Oh yeah. So now we're dealing with some high power views here. So again, telescope. This is a smaller chip than the APS-C of the Canon. This is dedicated astronomical camera. This is the ZWO ASI 183 color. So it's cooled, which is nice. Let's do temperature control. Thermal controls, cooler. Oh yeah, we're gonna turn the cooler on. Oh yeah. So we're gonna blow the cooler, and what that'll do is actually decrease the temperature on the chip, which helps get rid of our noise, which is exactly what we don't want. We want to get rid of as much noise as possible. All right, so here's what we got. I will get rid of that. We don't need, definitely don't need that. Here's what we're looking at. We have a view of the moon, and it's taking up, it's fitting almost on the entire chip. There's a little bit of spillover, but that's fine, and we can look at it. All right. Let's see. Yep. So we are still doing this because of COVID. It is still not safe to have gatherings. We are still listening to the experts' advice. We're listening to the CDC. We are listening to epidemiologists and not necessarily politicians. We want to do what's best for our community, not necessarily what feels right at the moment. So that's our issue right now. I'm going to keep doing this for as long as it takes. As long as necessary, as long as people want me to keep doing this, I'll just keep doing this because I think this is interesting. I think this is a lot of fun. And you can do stuff here that is really difficult to do in person. So in person is really great. It's fantastic. We need to be able to get back to the point where we can do it because you can look through a telescope and you can actually see something. I remember doing a star party years ago. It's probably been more than 10 years now, and we were at the Fort Worth Museum of Science and History, and we're looking at Saturn, and you could see Saturn in the eyepiece, and you could see the rings of Saturn, and it's very nice. And a woman was looking through the eyepiece, and she said, "Nah, I don't believe it. That's not Saturn. That can't be." And she didn't believe what she was seeing. And so while she was looking through the eyepiece, I just tapped the front of the telescope. Just a light tap, and it makes the whole image shake. And that's why you don't touch the telescope when you look through it. You just you put your eye to the eyepiece. You don't hold on to the telescope. All the stuff that you see advertisements and Hollywood stuff where people are holding onto a telescope like that, nobody does that. It makes the scope shake. You can't see the image. Okay, you just can't. Don't touch the telescope. You look through the eyepiece. So anyway, I tapped the telescope just to make it shake, just to show I'm not projecting an image. I'm not. It's not fake. It's not a camera somewhere or a video that's feeding into the telescope. It's not magic. I'm just magnifying the image, and just by tapping it and making it shake, you could see that right away. And then it doesn't shake for long. It all dampens out fairly quickly. But it's important. But there's stuff that I can show like this, which isn't so easy to show live with someone looking at the eyepiece. I can say, do you see the crater that has the rebound mountain inside? And they go, well, which one is that? Well, if this is what you're looking at on a high power view of the moon, I can say, well, it's the one on the left. No, the other left. And it's kind of hard to get that across unless you can get it right in the middle, and you can say, it's that crater right in the middle that you're looking at. Yeah, that one. Yeah, that one. The one that looks like that. That's the one I'm talking about. In this case, it's fairly easy for me to say, you've got a crater here. You can see the rebound mountain. You can see this part of the wall is in shadow, and this part is being lit up by the sun. You can see this rill. This is probably a fault line right through here, a crack in the surface. You can just barely see it, but it's most definitely there. Okay. Again, I'm actually looking at my other monitor in that direction, and I can see it better in there than I can on my laptop here. Laptops tend not to have very great screens, but it's fine. And I can go down, I can show these mountains here are being lit up by the sun when everything around them all through here is in shadow. This crater, just the tip of it, just the very lip, is lit up. Everything else, it's in shadow. It's the terminator. This is the where night becomes day on the moon. Go further, we can see, oh, craters within craters. So we know if we have a large crater and we have craters inside that crater, well, obviously, this one, the large one, had to form first, and the smaller ones were impacts later. Same thing over here. We have a large crater that looks like it's kind of eroded, it's kind of slumped down. Craters on the moon kind of erode, but not exactly. You have there is some erosion, and what's going on is you have basically solar wind, and solar wind breaks down some of the larger particles on the surface of the moon and turns them into dust. We call it regolith. It's this dusty covering on the moon. It also you can call it weathering, like we do on Earth. There is some weathering from solar wind on the rocks, and they become darker and duller. This is one of the reasons why I said if you look for the lighter colored stuff, lighter colored impact, this is material from below the surface that's been kind of brought up. It's been uncovered, is a better way of putting it. And it's lighter. It hasn't been exposed to the sun for as long. The darker stuff, the greater stuff, the duller stuff, I guess you can say, like this versus this especially versus that. This is much lighter. This indicates this is a younger crater. This is much older, and it looks kind of weathered. The surfaces are more covered in dust. This is an older crater, and this is the way that we age craters on the moon. If we were there, we could do other tricks. This is not exactly in great focus. I think I can get the focus a little bit better, but this isn't bad for now. We can still see a lot of details all through here. Just craters within craters within craters within craters. And it's not, you can see, now this is a live view, so you can see this changing. This is let's see, how fast is the view? A frame every 3.3 milliseconds. Well, that's the exposure, but we're doing 1.7, 1.8 frames per second. Maybe you can see that down here. Let's see. So, yeah, it's 1.5 frames a second, a little bit better than that. The reason why the frame rate is so slow is because this is a 20 megapixel chip. Yeah, I believe this is a 20 megapixel chip. So it's pushing a lot of data through. And you can see right here, oh, raw 8, no wonder. We're going to do RGB 24, not raw 8. It is going to kill our frame rate. No, it's not. It kept the same frame rate. Cool. Yeah, roughly the same, if not slightly faster. I do not want a SCR file. I want to do fits TIFF. I want to do a TIFF. Yeah, because I want as much color as I can. You can see just how big the area is. It's a big one. I can also do something. I can also say, well, just give me this area. I want a small, like what is it called? ROF, I believe it's called. It's basically the area that I want to focus on. If you're doing planetary stuff, then you don't care about everything around the planet. All you care about the planet. So only give me the data from these pixels around the planet. That's what we want to focus on. If you think I'm talking a little bit too quiet, let me know. I can play with the gain, get it a little bit louder, but the mic is fairly close. Hopefully you're not hearing the highway. It's gotten dark, so the planes are pretty much landed. We may have a couple more stragglers coming in, but not too bad. So this is at 100%. This is at 100%. If I go deeper, if I go 200%, so we're just doubling pixels. You can see a little bit of color noise, but that's not too bad. It's cooling, so it's getting as cold as it can get. Yeah, we can do this kind of stuff that we can't do live in person. Live in person views are important. We have to be able to show the public just what you can see through a telescope. When you do stuff like this is pretty cool. And we're just looking across at the moon. This is a very high-powered view, and it's just really neat. We can see craters upon craters upon craters. And this is not a super high power. If I had the CPC-11, I think I know I could get a lot deeper of an exposure. Um, so I could get more resolution. We'd be able to see this much, much better. The only issue with it is a very, very heavy telescope. And I thought about dragging it out, and it's a two-person job to get it up. And then there's the alignment, and I'm kind of thinking next moon viewing party, I may just defork it, which means pull it off of the fork and just use it on this mount. The only issue is that that's not much of an issue because it takes about 10 minutes to defork it and then about 10 to 15 minutes to put it back on. It's actually a fairly simple procedure. It's just tedious because the whole thing weighs quite a bit. And I didn't feel like experimenting with it today. That's what it boils down to. There we go. So we have a really bright little impact feature right here. So this is definitely a lot younger than the stuff around it. You can see that pretty well. I'm going to go back to 100%. See this kind of weird country. So what else can we look at? So I've got Starry Night over here. Okay, so we're looking at the moon. You can look at Orion. Um, and I want to get to the nova as well. So we'll be seeing that. Image histogram, what does histogram look like? Okay, so yeah, it's fine. I'm not going to do a live stack. There's just too much motion. I'm not doing any guiding on this at all. It's not really necessary at this point. We're doing a live view. This is what we want to see, especially for the moon. And you can see there's like, the image isn't stable. Not only does it move a bit, but there's also like, there's air motion as well in the upper atmosphere, and it sometimes makes it a little bit brighter, a little bit dimmer, just in and out of focus, kind of stretches it out in places. That's nature of the beast. Here we go. So we were looking earlier, let me get this open. Earlier we were looking at the crater over here, and you can see the ejecta. I think we can see the ejecta a little bit better this way. Let me zoom in. Yeah, so we can see the ejecta lines that are going out into the mare and then going in this direction. We don't really see anything here. So what that could be an indication is that it was at a lower angle, and then when it impacted this way, it blasted most of the material out in an arc in this direction and very little back. And what's really interesting is, unless it comes in at a very, very, very super shallow angle, the crater is going to be round. I mean, I think the degree is less than 20 degrees impact, so you can think of it as a flat plane. It has to impact like this for it to be an elongated crater, to be long this way. Anything like this, just almost any other angle above 20 degrees, it will make a round impact crater. This is kind of interesting because a meteor crater in Arizona is a round crater. Yet we know the impact wasn't straight down, it was at a significant angle. When Barringer was digging for that, for the iron meteorite that he thought was in there, he was digging straight down in the middle. And he found little bits and pieces, but he didn't find the whole thing. More of the mass was, and not all of it because a lot of it was blasted out, but more of the mass was actually embedded in one of the side walls off to the side, and that's not where he was looking. So it came in I want to say about 45 degrees, somewhere in that range, but it still made a round crater. And so on the moon, we typically see round craters because they either impact directly or within that angle. They typically don't impact in on the side. We do have a couple of examples. I can't remember off the top of my head where they are. There's even a chain of craters on the Earth, and they're still mostly round um, from multiple impacts of something breaking up. Yeah, so let's see. Any questions? Any comments? Whew. So okay, it's getting chilly. Uh, where is my where's my jacket? Sweater. Oh, there it goes. Okay, so I have yet something else to put on. I'm gonna put it on off camera. Don't need to see me get it dressed. So what do we have? We're looking at Tycho. Yeah, I think that's Tycho right there. Tycho crater, large, fairly large, but fairly recent. You can still see the ejecta. Um, just the ejecta lines are just out. Oh, oh, that's better. Slightly warmer. Couldn't find my hat. That's okay. This is not going to be nearly as cold, I think, as last time. Last time it was quite chilly, and fortunately, house is right there, so it's easy for me to just tuck in and get something warm to drink if I need to. Here's what we're gonna do. I want to see just how good of a focus I can get, and it ain't gonna be terribly good. Um, let's see. Let's see if we can get a good focus. So we're looking at the edge, and it is out of focus. So I gotta go back. Again, find focus. Is that better or is that worse? Better. That's better. Is that better? I want to say that's quite a bit better. Let's see what the rest of it looks like. Especially at 400x, that's not it's not great. Yeah, that's better actually. Okay. Yeah. So we're down here. It's drifted a bit, so we're not looking at the Terminator. Let's look at the whole thing, and then we can recenter it. Oh yeah, we got it. All right, I'm gonna hit the wrong button again. Oh, actually, that was the right button. How about this one? There we go. I got lucky that time. Oh yeah, that's a nice view. A little bit down. A little bit more. Too much. Okay, now this way. There we go. All right, so I'm going to take a. Ah, don't drop, don't drop, don't drop. Okay, let's do this. Let's take a. I just want to take a TIFF. Do a quick capture. Quick cap. No. Stop capture. All right. Hurry. Took 100 frames right just all together. I didn't want 100 frames. I just wanted a couple. Is this where I got it? Where is it? Where is it? Where is it? So I'm gonna go into chart cap. Let's find today's date. Today's the 20th. Captured. Got something. Got one TIFF. That's all I care about. I'm gonna set this up into open with shop. There we go. All right. So this is a full color, no filters, nothing on here. Just a full color image of the moon. That's pretty good. It's pretty good. 25%. Yeah, so we got some decent detail. And again, if I was going to be doing like really cool stuff, I'd be stacking, I'd be taking a bunch of images, but this is a single static one of the whole thing because I want to see what I can get out of this. So let's try this again. We're going to go to, let's do auto color. I'm just curious what it's going to come up with. That's just gray. That's fine. So we're going to do adjustments. I'm going to go into hue saturation. I'm going to bump up the saturation. Is that what we want? I don't think so. How about, anyone remember how to do this? Auto tone? No? Hopefully someone remembers how to do this because I thought it was just modifying the saturation and bumping. That's not what I want. That's definitely not what I want. Let's undo. Gonna go back. No auto tone, no auto color. Let's see what auto color does. Try the same thing. Adjustments, hue saturation. Because what I want to do is bring out. That's a little bit better. We don't want to bump it up that much, but let's just do this. So I'm bumping up the saturation. It's still kind of noisy, but that's okay. All right, so this is an enhanced color, I guess you can call it. So we can see some of this rock here. So obviously, is this a ray? This could be a ray that's still going across here. But we can see this part of the mare is one color, and this is what we were seeing in the view from the other telescope too. This part of the mare is one color, but we have a darker rock that goes all the way through here, even fills in. Looks like there's a crater right here that it's an older one that the material filled in. And then it's over here. So this color, it's similar to this, and I am not a lunar expert. I do not actually have a geological map of the moon handy. I guess we could always look it up. That's what the internet is for. But just by looking at this, we can right away see colors that we couldn't really see this way. I mean, we could see it in gray, but this kind of lets it pop out a little bit more, I think. In gray, it's fine, but this actually shows a little bit of color. So it's an indication of different types of rock. In this area here, this is all highlands. We don't have any mare there. But you can definitely see that the rocks in this area are different from the surrounding rocks. And it's pretty evident right there. So just going into, there we go. I'm going to zoom in. Center. Let's do magnify on there. So what I'm doing is actually looking at Starry Night. Where is it? Where is it? Where is it? Xenius? No. Labels. Space missions. Is that what I want? What I'm trying to do is this. So I've got the moon over here in Starry Night. So we're looking at this area right through here. And so this is Mare, Sea of Tranquility. Yeah. So I want to say that right over here is where the Apollo 11 landing was. I'm trying to remember exactly where it is. I don't remember. There's no show events. I want to do select the moon. I want to center the moon. And what I want is, oh, I haven't used this for a while. So I want space missions. View options. No. No, no, no. See, I've got space missions on here, but these are just going to be, oh, what do you call it? Those are just going to be satellites, not anything else. And there's a, oh, markers and outlines. That's what I want. Markers and outlines. I want a Apollo 11, Apollo 12, Apollo 13, 14, 15. That's fine. That's all we got. Apollo 17. Apollo 17. Okay. So where are we looking? We're going to look at Apollo 11. Oh, Apollo 17 is over there. Okay. So Apollo 17 is going to be right through here. Let's do center that. Let's just go do that. So Apollo 17 is what we want to see, which is going to be right in here. So Apollo 17 is right in that area here. go to live view. Over here. Yep. What are we looking at? Auto, 100%. We got a little bit of motion there, and the mount. So is this it? I want to say that's it. Go back to 50%. So we got this. This is flipped around. So this right there is Apollo 17. Go back. Here's that crater. So Apollo 17 landed in that area right over here. And no, we can't see the landers from the Earth. If you wanted to see that much detail, where we could resolve the landers, we would need a mirror 300 meters across. So Hubble is not capable of seeing it. However, we do have, let's see, there's a Japanese mission, and that's been doing HD images of the moon for a while, and it did fly over the landing sites, and to the point where they could actually see the tracks of the astronauts that they left on the moon. They could see the tracks of the rover, and see the descent stage for the LEM. That's the part that's left over, the legs and the landing engines. So Apollo 17 in this area. Go out. Okay. All right. And we're going to look at Apollo 11, and Apollo 16. So Apollo 11 is going to be over in that area, and Apollo 16 not too far away. All right. Back to here. Back to here. So Apollo 11 was in this general area, right? I'm just going to open this up in the other one, or on my other screen, so it's just easier for me to reference it. Apollo 11 is going to be where that crater is. These craters here, and Apollo 16 is right in this area here. No, wait. Hold on. Right when Apollo 16 is right in this area here. Yeah. Apollo 16 landed right over here, and Apollo 11 landed, let's see, across where this points, that line points almost to Apollo 11, and the Apollo 11 landing was right here. And from here, it looks nice and smooth. Looks absolutely fine. Turns out it was kind of rocky in the area where they landed, so Armstrong had to find a place to land and had to go a little bit further than he expected. So, all right, let's go back to the chat. Let's see anything going on. So we're viewing where we saw it. EK and Lunar Reconnaissance Orbiter. Yep. Okay. Cool. All right. So, how do we get good images like this? Equipment. That's the biggest thing. We need good equipment. And you know what? Give me just a second. I'm going to brighten up this image here. Is that better? I think it's a little bit better. I am the cameraman and the audio guy and the switcher. I have to do everything. So I just opened up the iris a little bit better on the camera, but it is a manual process. I wish there was a way I could do it automatically, but it's an older camera. I can't do that. Apollo 15 looks like it's on the very edge of the Terminator line. So it is actually I got Apollo 15. Yeah, Apollo 15's in down here. It is still on the night side, so we can't exactly see where Apollo 15 landed, but it was in this general area below what we're looking at. So back to Apollo 11. If you can see that little line, it kind of points almost directly to it and a little bit down. So Apollo 11 is right in this area here. Yeah, right in that circle is roughly where it landed. So again, it looks fairly clear of craters to us from here, even with a decent powered view. But once they were actually there were a number of craters. They landed next to a crater. Um, and there were rocks big as houses and going down. So he was quite lucky that he was a good pilot, and they were both able to come down. Neil Armstrong and Buzz Aldrin. So, what are we doing next? We've got the moon. Got quite a bit on the moon. Is there anything that y'all want to see specifically on the moon other than just the landing sites? Oh, here we go. Here we go. This is actually pretty good. Um, Slumped craters. So we looked at some along here, and we can see more little rebound mountains, fairly flat bottoms on a lot of these larger ones. And as we go to the edge, there's something I saw over here. Here we go. So these are some larger craters, and we can see that they're fairly complex. So you don't see just a crater like this that's blasted out. What you see are these complex walls. We have an outer wall here. We have an inner part here. And then we have the floor down in here. It looks like there's a rebound mountain right there too, or the remnants. We see the same thing over here. We have brightly lit outside, and then here we can see a little bit of detail. There's some shadow right through that line there, and then this is slumped down. What is this an indication of? Complex craters. When this was blasted out, all this was melted. Molten rock isn't exactly structurally sound. And so the crater walls here that were pushed out, there was nothing holding them back. And so they fell back in partially. And that's what this area here is. It's slumped material. So it blasted out, and you had these tall mountains, essentially, like you can think of it as mountains, um, of the crater walls, but there's stuff on the outside which is holding them and preventing them from falling this way, but all the stuff inside is now molten, and so it just kind of slumps back down in. And this is what we see in these larger craters. The craters that are at least younger is what we can see. Craters that are older, we may not necessarily see that anymore just because of basically weathering. We should be able to see some like along here. Well, we can sort of see it. You see the outer rim, and then you can see this kind of, well, these are actually craters. This is a crater too, so that's probably not the best of examples. Craters within craters, yeah, not the best of examples. Let's see if we can find anything closer to the Terminator. I'm gonna zoom out. Let's go auto again, because we're slipping. We're slipping. Is it right direction, wrong direction? No, wrong direction. And should be this direction here. There we go. Let's get that. Okay, here we go. There we go. I know what we're looking at now. We can see a little bit better here. You can see this slumping material. Yeah, I'm not exactly tracking. That's fine. And there's a little bit of wind too. So you can see the slumped down material here, and then the strong edge out here. So you have basically a slight rise to the rim, and then it's kind of jagged all the way down to a flat bottom, except for the rebound mountain here in the middle. Yeah, let's go to the edge. Older with the rebound mountain. Trying to find any more complexity like that. In the larger ones, you can see this. Down here again, it's not a stark crater wall like these here. This one here, it has that flat bottom, and this is kind of like, you can think of it as almost like rubble, because the edges were very, very strong at impact, but because there's no support that's holding them, they just kind of slumped and collapsed in. Now, they didn't collapse all the way in, because for a lot of this, the magma was cooling very quickly. Remember, so these are impacts that went in deep. I guess you can't really call it magma, it's just molten rock. So the molten rock, it cooled off fairly quickly. unless it's a big, big event like the creation of Mare here, um, it's going to cool relatively quickly. The Mare may stay molten for, I have no idea, days to weeks, because this is punched all the way down into the mantle, and this is mantle material that's coming up. For these craters, even the larger ones, it melts the inside, but I don't think it punches all the way through the crust to make it down into the mantle. This is nice. This is a good view. I'm pretty happy with this one. I think I like this one better than through the DSLR. You get a little bit sharper. Um, it's a smaller chip, so we can see more details. The pixels are actually smaller than on the DSLR. And this is kind of the next upgrade step. You go from hooking up an unmodified DSLR to your telescope. Then you go to modified DSLRs. Then you go to cooled cameras. Actually, no. Then you go to uncooled cameras. Then you go to cooled color cameras. And finally, you say, I want data. And you go into monochrome. And once you start shooting monochrome, that's a whole other ballgame. Let's see. Any questions? Ooh, yes. Patrick saying that, know, years ago, let's just call it 30 years ago, someone doing something like this would be just absolutely amazing. The technology did not exist to do something like this. One, there was no streaming like this. Two, the cameras were just nowhere near this. We had like 320 by 240 at the most for pixels, or even less. Typically, it was less. 160 by 80, 160 by 120 pixel cameras. They were slow. We had them connected by parallel port. So you would take an image and it would take like 4 or 5 seconds or more to download. And you look at it, it's like, well, that's out of focus. And you gotta crank it, crank it, crank it, and keep doing it that way. Um, Laptops were incredibly slow. Um, and you just didn't get that good of image. And also back then it was film. People were doing still everything with film, and so you had to hyper your film. You cooled it and ran it through. You sucked out all the oxygen in a vacuum chamber, and you replaced it with nitrogen and argon. Like this, it's called a hypering gas. It's like nitrogen and argon to push out the oxygen, and your film became much more sensitive that way. And then you would take your images and you would do manual guiding with the cables, and you have an eyepiece with a crosshair in it, and just try to hold that 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 star right in the center of that crosshair. And no, I did it. I will never return to those days again. Uh, they sucked. They really did, because you would work all night. You had no idea if your image was going to be good until you got it back from the developers. Here we go. We have a crater wall here. I'm sorry, crater wall. We have a cliff wall right here. Another cliff wall right through here. So cliffs are on the moon are pretty much formed from faulting. Um, um, all right, so hot things expand, cold things shrink, right? And what happens on the moon is no different. So the moon, as it's been cooling, has been shrinking. Well, if your crust is fairly solid, but your inside shrink, the crust is going to buckle in places. And that's what we see with these fault lines here in these cliffs. So it's just an indication that the moon is slowly cooling. And we see them in lots of places. So it's not like it's anything, terribly rare. Um, but they are always interesting. We have the rills. We're looking at some other, here's a fault line or a rill all the way through here. It's a fairly long one. This is not a road, people. This is not a road on the moon. It's just a crack. And that's quite nice. So we can see, if I zoom back out to auto, it's drifting because I'm just not guiding. I just didn't bother guiding. See, yeah, so John is right. We talked about this earlier, that the brighter patches, all these bright impacts up here, these are younger. than the darker areas here because of solar weathering. So older craters are darker because solar wind, particles from the sun impacting on the moon, break bigger rocks into smaller rocks very, 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 very slowly, but essentially turn everything to dust. And dust has a dust does not reflect like fresh rock does, so it's duller, and it also tends to scatter light a lot more too. So the brighter areas, like right there, there's a bright impact feature, there's a bright impact feature, these over here, you know, all of those are younger impacts. And also when you see the ejecta lines also kind of get weathered over the years too, so they're not as bright. Um, they will get, you know, duller and grayer. All right. Anything else on the moon you want to see? Let me know. Let's see. What's a bright point by 11 by Apollo 11? Um, that one right there. Let's find out what that one is. I don't remember what that crater is called, but I can find it. Let's see. Apollo 11. What is that crater? That looks like it's that one right there. Yeah, it looks like it's that one. That one. What is this one called? Censorinus. That is Censorinus crater, apparently. So here is Apollo 11, right in this area. That spot, that crater is Censorinus, like censor, I-N-U-S. This one right there is called Theophilus. We have Theophilus, and then next to it we have Cyrillus, and then this one is Katharina, Cyrillus, and Theophilus, right here. 3 craters in a row. We have Apollo 11, and then looking at Apollo 17 in this area over here. So Apollo 11, Sea of Tranquility, and you look at this little scar line here, and you kind of take the curve, and it is just below the end, right over here. Yep. Where it kind of peters out, it's yeah, it's right over there. It's not as far as this one. It's just over here. Not as far as this crater. Right in this area here. So we got Apollo 11. So that's a nice view. I'm pretty happy with this camera. It's a good view. It is not a top of the line camera. Top of the line cameras can be very, very expensive, and I highly recommend buying used. It's always going to be quite a bit cheaper. If you can't afford expensive equipment, I would always start off, get stuff that you can reuse. Buy stuff used, get stuff that you can use for something else. If you have a DSLR at home, you can start taking astrophotography with a DSLR and a tripod. There's something called the rule of 500. Look it up. It will tell you for your chip, for your camera, for your lens, this is the maximum exposure that you can take at a focal length so the stars don't trail. If you want trailing stars, that's absolutely fine. You can do that however you like. But you start off with a DSLR and a tripod, and then you work your way up. You can get what's called a star tracker. I have one. May want to play with it next time too. It's called the Sky Adventurer, and what that does is once you have it aligned, it will follow the rate of rotation of the Earth. So it will keep it'll keep pointing at like the same object for a while. It's not that great. So you can't do a 15, 20 minute or hour long exposure. You're going to be limited about 30 seconds, a minute, 2 minutes. And you're always going to be doing wide angle stuff. So you want like like you put your DSLR on there and you do like a 50 mil or a 85 mil or even I think you can go up to 200, 300 mil for focal length. but at that point it's kind of iffy. Um, but you can do some of these wide angle views, and they're not terribly expensive, and you just pop your DSLR on there and you get everything aligned and to the celestial North Pole, and then you're good. And from there you can upgrade to equatorial mounts. You can get low end ones now easily under $1,000, that you can have your camera on, and your regular lenses. Once you graduate from that, you go into small telescopes like 60 millimeter, I think it's like 60 millimeter f5 or f6, 80 millimeter f6, um, and you can do wide angle stuff with that too. And you're slowly going up, but I would highly recommend getting stuff that is, um, get it used, let someone else, be at the bleeding edge of technology, let them pay, the what do we call it, first adopter tax. And once the newest, latest, greatest stuff comes out, they sell their stuff, and they buy the newest stuff. We actually have several club members. You know who you are, because I'm looking at you right now here in the chat. You know exactly who you are. You buy the latest and greatest, and then you sell the stuff that is no longer the latest and greatest, and the rest of us pick it up at a really good discount, which is fine. Um, because we always have people who need to be on the bleeding edge, who take the best images, who have been doing this for a while, and then you have the rest of us who are perfectly content to do stuff like this. Um, I would love to take much better images, but it's kind of the thing where, um, I like doing this, and this takes away from astrophotography time. So on a night like this, I could be imaging the moon for hours and hours and hours, and I can come back with a really great picture of the moon, or I can just do a star party. And I enjoy doing this. And if it's a really nice night, then I may, especially on the weekend, I may want to just do a star party and just do some deep sky stuff and show that, as opposed to me sitting out in the dark and taking images. I know that a lot of people, that they love that, and that's absolutely fine. There is plenty of space for everyone to do what they want, as opposed to like everyone goes into this niche. Everyone has to do deep space photography. No, they don't. There's plenty of people who only do planetary. I actually met a guy. He only did solar. He didn't care about anything else. He only did solar. He did hydrogen alpha. He did calcium. I think he did potassium. Don't remember if he did potassium or not. He focused on the sun, and that's all he cared about. So, nighttime, he was asleep. He didn't care. Didn't even do the moon. Didn't look up at the sky at all. He didn't care. During the day, if it wasn't cloudy, he'd be out with his solar scopes, and he was doing imaging. That's all he wanted to do, and that's fine. And I know someone else. All he cared about was the moon, and that's it. Didn't worry about planets. Didn't worry about anything else. He spent his time just observing the moon, imaging the moon, and that was his thing. And there are people who just do the planets. Well, they do the moon and planets typically, but they focus on that. They don't do the deep sky stuff. And then we have other club members who do absolutely everything. They'll do deep sky, they'll do planetary, they'll do lunar, whatever's up that night. That's what they take pictures of. Okay. Any other questions? No. All right. Uh, so back in the olden days, you really didn't have photography. Photography was something that was, what the professionals did. Instead, what a lot of amateurs did was pencil and paper, and they would just draw. And something that you could actually buy back then was black paper and white pencils. So you would look through your eyepiece, and then you already have something all in black, and you're just drawing in stars, you're drawing in a galaxy, you're drawing in a nebula, and you're doing observing. Um, and that's fine. People still do that these days too. You can actually, I think for the Messier, the Astronomical League's Messier certificate for completing the Messier list, um, they like to see that. They don't want photos of everything. They definitely don't want the messy marathon. What they want is someone to observe an object and draw it. Just draw, 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 draw. Because that forces you to really look at it. Um, my problem is my eyes aren't so good anymore. I actually had really poor vision. I wore contacts for a while, and then I got implants, and the implants had to come out in 5 years, about 5 years, because they gave me cataracts. So now I have lens implants, and I can see, but I need reading glasses, and I have a lot of floaters. So when I'm looking through the eyepiece, I just see so many floaters going through that I just can't see the images as well as I could when I was a lot younger. Uh, Not really that old now, but it kind of sucks. So for me, doing this, I see this now much better than I ever could through the eyepiece, and I'm just happy to share it. I think it's a lot of fun. This kind of looks like someone just took a paintbrush and just swiped it across here, but it's not. It's a different rock. All right. Anything else on the moon, or are we good to go on? Because just looking up, I'm hoping we can see. I don't know what we can see. I have no idea. Let's do. I'm going to switch to a different camera. So I've got a bunch of cameras on here. Um, this camera right there will give us our full sky view, 50 milliseconds, which does us no good. We need not that much. RAW 8, RGB 24. That's what I want. What I need to do is switch that to something else. Where am I looking? I don't want to see the moon. Give me something. Oh no. Oh yeah, this camera. Reconnect that camera. Let's see if I can. Let's see if this works better. Oh no. Yeah, this camera is. What's the proper term? Borked. Yeah, camera's borked. Well, that's always fun. All right, that's that. Let's go to the other camera. Yeah, we're just kind of drifting a bit, which is fine, I guess. So we got the full view. This is my basically my finder. So I'm gonna do this. We don't have anything else on the moon. No, no one's got any other questions. All right, so we're gonna go menu, and I'm going to do select and slew. Let's go to M42 Messier catalog. Let's see, 42. Enter. We're gonna go to the Orion Nebula. Be hitting nothing. All right. What are we looking at? I don't know. We need longer exposure. Anything? Oh, we need a longer exposure. Oh, definitely need a longer exposure. There we go. What do we got? 4 seconds. Let's see what we can see in 4 seconds. Oh, here we go. There's the Orion Nebula right there. So we're looking at the trapezium. 4 stars in the middle. Yeah, we're looking at the trapezium. Okay. Let's give it 8 seconds. Mono. Go mono 16. A little bit deeper. 8 second exposure. This is essentially my finder scope. We'll see just how much detail. Yeah, we can see a little bit of nebulosity through here. All right, so we see 4-ish stars in the trapezium. And yeah, this is not a very good finder. It's good enough for guiding. This is the, what is it? This is the Orion 70 millimeter multi-purpose finder. Again, not a terribly great one. It's fine. All right, how am I lit up? I'm going to dim this thing down so I can actually see stuff. There we go. How's that? So I have a overhead light, and that should do it. So hopefully it'll also prevent light from shining into the telescopes. I have a little grid on here, so that does help a bit. Hoping. All right, let's see. Let's switch over to this guy, and we're going to take some longer exposures. Do not want that. I need to do a profile. I'm going to do TIFFs, not right. We're going to do RGB 24, and we're back on. Long exposure mode. Let's do 8 seconds. Yeah. Okay, cool. Got something. Let's see what we're looking at. Auto. Cool. All right, so we're looking at Orion Nebula. We can see the trapezium. All right, there's definitely a trapezium there. So I'm going to do 100%. Cool. So we're picking up some stars. They're roundish. Remember, this is unguided, so we're doing fine here. All right. All right, Patrick's going to open up in his 12-inch Dob. Yeah. So actually today, we had a gentleman who contacted the club, and I read a post, and he actually has donated to the club a 10-inch Orion Dob. So one of our club members actually picked it up this afternoon, and it looks like it's in pretty good shape. We're going to see what we can do with it. It's going to go to the board and officers, and the board and officers are going to decide. Now, we do have we do get donated telescopes from time to time, so if anyone has a telescope they're not using, they don't want, as long as it's in good shape that we can actually use it, we will accept donations. Please don't give us your Sears Special, your Walmart scope from 10 years ago that has a big dent in the side that's been in the closet now since that Christmas. It's not a very good telescope, so we don't really want it. However, if you have something good, a nice scope that you want to donate and pass on, I actually have one telescope I have one telescope which was donated to the club for a raffle. It's actually an astrograph. It was donated in February of 2020, and it was supposed to be a raffled off in March of 2020. March of 2020 was when I was president, and we went to virtual meetings. So we have not had an in-person meeting since. And this is actually, I haven't checked, but I think this is the 1 year anniversary of me doing these virtual star parties as well. Uh, I want to say it was about March. It was either March or very early April when I did the first one. So, yeah, I've been doing these a year. Now, time flies, doesn't it? I think I've upgraded my game just a bit. It looks a lot better now than it did that first time. So, uh, yeah, with a 10-inch scope, it should be a very good one. So we'll decide what we're going to do with it. But in the meantime, one of our club members has it, and she's going to use it for now. And when we get back together, we're going to decide what's going to happen to it, whether it's going to get um, uh, used at one of our dark sky sites, whether we're going to raffle it off, whether we're going to donate it to an organization um, that could use one. We'll see. It's not for me to decide, it is for the board to decide. It is now a club telescope. So for John, I'll pass on that information to you. I've just been kind of busy getting this all together already, so I haven't had a chance to. Okay, so Orion Nebula. We're going to try to do some imaging of the Orion Nebula. It ain't too pretty right now because, excuse me, we're not doing any guiding. So here's what we're going to do. We're going to go ahead and do some guiding. Push here, dummy. PhD. Yeah, let's do that. No, Microsoft, we're not going to do that. No, Microsoft, we're not going to do that. Microsoft wants me to please, please, please fix my password. So pick one. I'm going to pick that one. Connect, connect, close. Go. We're going to do, let's see, get looping. We do 3-second exposure. There we go. Let's do 2-second exposure. So here's what we got. We can definitely see the Orion Nebula here. I'm going to pick that star, and we're going to clear calibration, and we're going to let it calibrate. So for those of you who don't know what this step is, I have to train the mount. No, is that the right word? I have to train the guide camera and software to use the mount. And the way you do that is you have a guide camera on a guide telescope attached to the mount, and then PHD stands for push here dummy. It will go ahead and nudge the telescope in one direction, so it'll nudge it north, south, east, west, and figure out just how far it's moving for every nudge. And from there, it calibrates itself and realizes, oh, okay, I need to be pointed, or if I need to keep this star over, can't even see that. So in the view here, oh boy, here we go. See, this is for the focus. Okay, in the view over here, it's I don't know what we're looking at now. So, oh, yeah, it's kind of off. So there's a star right there. That star here. It's trying to keep that star as close as it can on just 1 pixel. And so when it sees that it's kind of moved off, it has to fix itself. So I'm going to go ahead and clear that out, and let's see what we can do. So we want to let it settle. And this is a 2-second exposure. So there's a little bit of wind. It's not terribly bad. And it's not nearly as cold as it was last time. It's 9:30 already. Okay, we'll see. So here's what we got. We'll let that thing guide. Come back to here. Stars aren't too bad. Let's see what the next one's going to be like. We're going to go from 8 seconds to something a lot longer. It's not horrible, not great. All right, let's do a quick picks. Let's do a 30-second exposure. And then I'm also going to jump back into here. We're going to, of course we are. Of course we're going to do that. So I'm going to go back to Backyard EOS. Let's let that thing open up. In the meantime, we'll come back to here. Come on. Come on. Come on. There we go. So we're doing a 30-second exposure. Let's see what we look. All right, we got something. Let's knock back to auto. Okay, we got something there. Not great. We need a much longer exposure. And remember, I have no filters on this thing whatsoever. So what we got is what we got. Let's do 60-second exposure. And then we're going to come here to Backyard EOS as well. Connect up to the other DSLR. And again, I have no filters on this thing. I should probably put filters on it. It's fine. We'll survive. I'm going to do a 1 exposure, bulb duration. Let's do 60 seconds. So we do a comparison, and I'm going to do 800 ISO. No pause. Start the capture. And so it'll do a 60-second exposure, and then it'll do another 60-second exposure with the shutter closed for a dark frame, and then it'll do automatic subtraction of that dark frame. That's not what I want. This is what I want. So the difference is with the cooled camera, we don't need to take a dark frame right afterwards. This is a fairly cool chip. We should take a dark frame anyway if we're going to be doing some processing, but we're not. Ooh, well, that's kind of pretty. Stars aren't really round. Guiding isn't great right now. It's getting kind of cold right now. Let's look at the graph. Yeah, it's kind of, it's not that great. It's not horrible, but it's not great. The corrections, yeah. So we're seeing some corrections. It's hard to tell with a trend line this early on, but yeah, it's not. Ugh, RA's kind of off. I think there's just some slop. Um, no, no, it shouldn't be any slop in there. It's probably just the wind. There's like a little bit of wind, and there should be a dip now. Yeah, we're getting a little bit of wind blown around. It's fine. We're not doing any serious imaging. I'm not worried. Fixed image. Yeah, this one's a little bit better. A little bit rounder. We can see nebula over here. This is M42. This is M43. Yeah, this is M43 probably. Um, so yeah, we can see the wings coming out. You can see the difference all through here. And then if I do, let's just do a longer exposure. Yeah, I'm not going to waste time for that. It's cooling, a 60-second exposure. Let's do a 2-minute exposure. And the nice thing about these cameras also, there's no shutter. It doesn't make it shake. It just starts imaging. That's what we got here. There we go. Ah, yeah. So, totally different image. Lots of color. You see the nebula in there, but oh man, is that just, what is that? I don't need to see all that. I definitely don't need to see all that. There we go. Uh, Lots of vignetting. But oh boy, we don't need to see. How about that? Yeah. Barely make out the Running Man over here. There's a Running Man nebula, but yeah, lots of light pollution. So we're in town. Light pollution prevents us from taking a good image. So how do we fix it? We get a light pollution filter. That's what we do. So by putting a light pollution filter on here, we can cut out a lot of extra light. The sodium vapor light from street lights, we can almost all eliminate that. LEDs are something else. Mercury vapor, we can get rid of that. But yeah, LEDs are kind of a broader spectrum. They're a lot harder to eliminate now, which there are pluses, there are minuses. They use a whole lot less power, but for us, it's. Now let's see, anything going on? John, yes, that nebulosity is around the trapezium, so we've gone way past that. Sorry, there's like a 30-second delay between when I say something when it goes out live. So and the chat is way over on the other side. So I'm going to go grab some light pollution filters. We're going to put the light pollution filters on there. Let's see what this image is. Oh yeah, there we go. So we can see some more of the detail. And you can see this is not noisy at all. Let's go ahead and zoom in 100%. Yeah, we've gotten rid of a lot of the noise just with the cooler on. So what is this thing running at? I think I was looking earlier. Here we go. So, so the cooler is running at minus 24 degrees Celsius. And with this camera, there is a little heater around the edge which prevents dewing and frosting, which is what we want. But we want the chip as cold as possible, so the chip is pretty good. Yeah, it's a little bit of elongation. The guiding is not great tonight, so we'll deal with it the best we can. So I'm gonna go, and I need to, let's see, I need to get my filter case out. So one moment. All right, one filter case. So what do we use filters for? Filters block out light. You get filters which are, like old school filters, which are colored filters. Think of it like a gel for photography. Uh, so you have like warming filters, which are orange or typically orange reddish. You have cooling filters, which are bluish. Um, those just change colors. We don't really want to change colors. Not exactly. What we want to do is block certain wavelengths of light. So, where did I put my stuff? Wait, I think I did put one filter on there. Yeah, I did. All right, we do have one filter on the DSLR. Okay, so I do have a light pollution filter on there. It's just not enough. It's just that much light pollution. And also, I'm wondering if whoops, if I actually look back, yeah, there's not a whole light really shining into that camera, but just to make sure, we'll do this. Or not into the telescope. I'm going to. I think you can just see my glasses and nothing else. So what I'm going to do on here, oh boy, I'm going to go in and whew, let's see if I can do this. Because you can barely see me, and I would like to be able to be viewed a little bit better. So I'm going to go to. So I've got to find where my deal is, and okay, yeah, I gotta do it that way. Nope, nope. No, where is it? Oh, there it is. Okay, so I've got to do this. Gotta do this. Do that. And color. Ah, there we go. Whoa. Okay, how's that? You should be able to see me now. Kind of greenish, but you should be able to see me. So what I did is I just bumped up my what I do. Oh, I bumped up the gain on the camera, which now kind of sucks because I have to make myself quite a bit brighter because I've got to put the filter on here. Is this still going? Yeah, it's still going. I'm going to take another image off this one in just a minute because I want to see if it's actually just the light shining into it or what. I think we double stacked this before, so I don't think we're going to be doing much deep sky stuff just because the amount of light pollution, even with light pollution filter, is kind of iffy. All right, leave it on here because, yeah, we're going to have to focus, have to refocus. So here we go. So this is a light pollution filter. And this is a Optilong L Enhance. Yeah, so this is I believe this is a dual bandwidth one. All right. So, yep. So that camera's nice and warm. I should really just warm my hands on it. Uh, yeah, this was. We need to drop this down to about 8 seconds. Let's do an 8. Oh yeah, so you can see. It's all lovely. Okay, it is no longer in focus, which is fine. That's what it's supposed to be. Uh, Got way out of focus. So what do? Gotta focus it. And just for kicks and grins, we're gonna look at this in just a second after I focus it a little bit further down. I actually can't see it from back there. So let's see what it does. Is that bigger? Is that smaller? Let's see what it does. Okay, smaller, good. I'm gonna have to do gain. Yeah, we're gonna have to bump the gain way up. So 8 seconds. Okay, This is a defocused diffraction ring, and I can see that it's not exactly collimated perfectly anymore, which is it's fine for tonight. But if I was going to be doing some serious photography, I would definitely want to recollimate this thing. Uh, where's my gain? Gain. I want to bump up the gain quite a bit. Um, and what we're actually seeing is with these spikes, um, the light is bending around everything. This blockage right there, this black spot, this is the central obstruction. Um, this is the mirror, the secondary mirror that's being held up, and these areas here, these spikes, are actually from the spider. So, all right. Overexposure, just so I can see what's going on. Oops, out. 4 seconds. Okay. And yep, how this works. Ooh, kind of abstract. Okay. Getting there. Okay. Getting there. Getting there. Okay. I think we get a little bit better. Actually, I have my Patinoff mask somewhere. Where did I put my mask? Okay. So if you remember from last time, we were doing focusing, and oh, man, here we go. So we were doing focusing using the Batinov mask. Now I have one mask stuck inside the other mask. So it's fine. We're fine. So here's the Batinov mask. Kind of see it right here. This is what we'll be using, well, to get the fine focus. And then, once we get done with this one, I want to go look at that new Nova in Cassiopeia. All right, we got the mask on there. What are we looking at? How close are we? Ah. I think we need less. Here we go. Lots of gain, faster exposures. Here we go. We are off. We are really off. So what we can see is the spikes through here. I'm going to zoom in a whole lot more. Let's go to 100. Yeah, that's what we want. This is not what we want. We want to look symmetrical. 2-second exposure. Let's go a little bit more in this direction. In. Better. What we're looking for is symmetrical patterns. That's relatively symmetrical for what it is. That's actually pretty good right there. It ain't perfect, but it's almost there. I think I can go a tiny bit more. Hope I didn't go too far. Let's let it settle. Almost settling. Yeah, that's gonna be pretty good. Yeah, it's good enough for me. So now we have good sharpness. And what we're looking at is a diffraction pattern. That's a quantum mechanical effect. Cool. All right, we got that. Auto out. We have a light pollution filter on there. And let's go for, let's do a 60-second exposure so we can see. So we're guiding. Let's see how well we're guiding. Okay, well, not great. I've had a lot better on the RA. I mean, I've had a lot better with this mount. I think today is just, I think it's an off day for the mount. We got that going. Okay. This guy, yeah, I don't think we're going to get that great of an image with this guy. Um, yeah, 60-second exposure. We can try again for 60 seconds and see what happens, but I'm pretty sure that we're going to get much better images out of this one. It won't be as wide angle, but it'll be nicer. So on here, actually have a zero point 0.8 reducer flattener on the 8-inch Ritchie Creighton. So that gives me flatter. The idea is that, ooh, that's not bad. The stars are rounder towards the edges of the image, and if I was better collimated, it's pretty good for collimation. I'm actually pretty happy with the collimation. If it was a little bit better, then we could guarantee we have very, very round stars all the way around. It's good enough for me. If your collimation is off, you're never going to get really good focus. All your stars are going to be kind of elongated, or they're going to look like a little cone. You'll have a little bright point, and then it'll just kind of spread out in one direction. And you don't want those. You want nice little round stars. Okay, so for a 60-second exposure, it's not too bad. So this is everything. Now you can see this is way blown out. So what I'm going to do is I'm going to take my gain, and it says auto gain. I'm going to take my gain way down because I want to show. Now let's do another one. This is what we're really looking at. The gain is just gain just changes the levels of the pixels. It doesn't actually add any data. All it's doing is letting you visualize better what's there. All the data's there, but if you blow up the gain way too much, then your anything that's white is just blown out. We want to be able to see the core. We want to be able to see the stuff on the outside. So you drop your gain way down when you're actually saving data, so that you can then import that in another application. You do your stacking, then you get the data, and then finally you bring it into Photoshop or PixInsight or whatever application you use, and then you start bringing out your image. The gain that I'm doing right now is just so we can see what's going on, and I don't care if I blow out the middle. I want to see the outside. So let's see, 60-second exposure, what do we get? Yep, that's what we got, 60-second exposure. So I'm going to do a capture. Jeez. Start capture. And I'm going to do number of frames. I'm going to do, you know what? I'm going to just do 2 frames. 21. Oh, just 2 frames. That's all I care about right now. Start. Okay. So whatever it's done, it'll take a frame. Let's look at backyard EOS. So it took an image. It's done. There's a lot of light pollution. There's not really anything I can do about that with that camera and with that filter on there. I think if I put the Optolong on there, I could get somewhat better results. I'm not 100% positive. So I'm going to go, what am I going to do? I'm just thinking about something else now. I can't think about it. I thought I had another filter. I could have sworn I put another filter on here. I really swore I put another filter on here, but it doesn't look like I actually have one. Okay, we'll deal with it. Let's see what this looks like now. Because what I want to do is take this frame, and once it's done, I want to bring this up into Photoshop and just show what we can do in Photoshop, what actual data is here, as opposed to, well, here's the trapezium, here's some stars, here's a little bit of nebulosity, just something is in there. We want to see some more. So if you have any questions, comments, let me know. You can put them in the chat, and I will take a look. Still coming in. A couple more seconds on this first frame. And as soon as this pops in on here, yeah, as soon as it pops in on there, I have it on another screen here. I will go ahead and bring it up. This is it. Okay, one is captured. Come on. Is it saving? Captured up. It created a brand new folder. Good job. Is it? Where'd it go? Capture. 21. There we go. Okay, second set of captures. I have one. Okay, cool. Bring this to Photoshop. All right. That is the image we just captured. 1 minute of exposure with a cooled camera. What do we got? Let's look at the curves. Okay, we got lots of black and almost nothing in the white. All right, start playing with it. Ooh. Hey, we got something out of it. This is not a huge amount of data. I'm not going to mess with that. How about this? Typically, we do stuff like this. We do, instead of curves, we do levels. So you hit the level, and you go like that. You just keep going, keep going, keep going. Well, what do we see? My bit depth sucks. That's what we see. So there's a whole bunch of nebulosity, but you can see there's no difference between this color and all the colors around here. This one's really flat. It's not a nice gradient. It's just like hard steps. So obviously this is not a very good image. We're not going to get much out of this without me really messing with it. I don't feel like messing with it. This is not. Let's see what the type of image is. In mode RGB 8-bit. Yeah, 2016. So what do I have it on here? RGB 24. Maybe it should be raw 16. I can't remember now. But that's of that. Let's do gain. Auto gain. See what it does. And in the meantime, I'm going to come back to this one and I'm going to see, do I actually have a light pollution filter on there? Or did I just fool myself? So let's see what we got. This one has a reducer on it as well. It's a different kind. It's a Hutech flattener reducer for this telescope. Gentle pulling it out. Yep, I do. This is the ITAF one. All right. Oh well, I was wrong. There's light pollution filter on here. And there's just way too much pollution to deal with. It's what it is. There's nothing I can do. Look at that. I think we're going to use this. We have to refocus. There's just no way I can work with this. So we're going to do frame and focus and use the Batinov mask. There we go. Okay. What are we looking at? We're looking at something bright over here. Yeah. Okay. So that's a star. We're going to use the Batinov mask again and duration. Okay. So we have another Batinov mask. So we size them differently depending on the different telescopes. So this is the Batinov mask, which really can't see. How's this? This is probably a little bit better. There we go. So this is sized. It does the exact same thing. It's just sized for a different telescope. And you can actually get Batinov masks that are sized for DSLRs and DSLR lenses. And there's some neat stuff which I've seen before. And what that is, let's see, does this work? It's way off. what I've seen before for them is they're actually etched. I'm not seeing. I'm really not seeing anything on here. Hmm. I think we're actually pretty decent on the focus then. Yeah, I think we're pretty okay on the focus. So I'm not seeing much of a difference anyway with the band of mask. Maybe I shouldn't do the live view. Maybe I should just loop it. Let's see what happens if I do a 5-second loop. What happens? What's going to happen? So what I've seen before, it's like a clear piece of plastic, but the lines are actually etched into it, and it creates the pattern. So instead of blocking the light, it just forces the light to go. Oh yeah, cool. There we go. Yeah, that's pretty good. That's actually pretty good. Okay, works for me. All right. All right. Well, don't have to mess with that anymore. But yeah, this is not great. Thrilled with that. Maybe it's just not that great of an image. It's just not a good. It's just not taking good images today from the city. But it is what it is. What about this? 60-second. I thought I got my gain. Guess not. Let's punch up the gains. See what happens. Anything, anything at all. What do we have? Yep, yeah, a little bit. We really need a longer exposure. So I'm just going to do kicks and grins. We're going to do a 3-minute exposure. See what happens. It's decent gain. Let's see what happens. All right. So I was looking at this earlier. We have, let that thing go. So we have a new nova in Cassiopeia. So here's the article from astronomy.com. And I saw it earlier in, oh shoot, there was something else. Science Astronomy. Can't remember what this site is. So where are we looking? We're looking Cassiopeia. There's a new star right about there. So, oh man, this is not going to be. Oh, this is going to suck finding it. It's okay. We'll deal with it. Oh man. So we have a nova, and we got to find it. So Cassiopeia, and we take that arm, and it points almost at it. So here we go. Shedar to Calf, and almost and a little bit down. Okay. Okay, let's see what we can do. I'm going to let this thing go. Yeah, we wanna make sure we at least finish off this image and just do the start capture. Yeah. Let's capture the next 2 frames. To see what they look like, and we'll go from there. I will reboot that wide angle camera. I think that camera is just it's the ASI 120 MCS. I'm not sure what's wrong with it. It's kind of I really don't know what's wrong with it. It seems to be kind of buggy, where it will drop connection. I still don't know why. It'll just drop the connection every once in a while. Then I have to go in there and reboot it. Sometimes it works, and sometimes it doesn't. Um, but that's been kind of my workhorse planetary camera for many years now. Um, and then I have another planetary. So my other planetary camera is also ASI 224 MC, and That camera was actually given to me by one of our club members. Uh, he let me borrow it. Um, and I think it was about 2 years ago. He let me borrow it one night and then he went home. And Bill Nichols was just that kind of a guy. He would let you borrow stuff if you needed it. And the thing is, I kept asking, and because I totally forgotten it. It was in my box for like a month or two, or maybe even more. And when I finally realized, I was like, I don't remember buying this. And I kept asking, and Bill didn't speak up. So Bill actually passed away earlier this year. We were at the memorial a few weeks back. Uh, yeah, that's the second thing that I've gotten from Bill. So I also have a 5-inch Meade refractor that Bill gave me because he said he was tired of it being in his garage. I think that was the last swap meet that we did 2 Novembers ago. And yeah, so he gave me this big telescope, just said, here, take it. I don't want it. And so I have yet another telescope. So we're seeing some good detail in here. Trapezium is all blown out. It's just going to be all blown out with the type of images that we're doing right now. But we can see detail. We can see some of the red and the hydrogen here. We can see some of the dust bands. This is actually pretty good. I would take this image, not here. I'd be taking it in a dark sky site. But this isn't too bad. This isn't too bad for the city, especially if we're just showing off stuff. But again, trapezium is all blown out. So the inside core. So all the stuff here, all the gases here, they're nice, they're bright, they're being lit up by the ultraviolet radiation from these hot young new stars. All right, it's 10:08, and it's not terribly cold. What temperature is it? I got 57. It's not bad. Not bad. Could be worse. Could be a lot colder. All right, so this next image, we've got another minute on there. We'll see what that's like. See what this got. Yeah, I'm not expecting much. But on the plus side, what we will be able to do with this is see more of Cassiopeia. We'll see if we can narrow it down to exactly where this star is. And yeah, 42 seconds. We'll let the thing finish, and then once it finishes, I will reboot the other camera because I don't want to touch it while it's imaging because it's just going to introduce shake. I don't want to do that. We'll just wait. Ooh. Yeah, my hands are getting a little bit chilly, and this outer sweatshirt does not have pockets, so I have to go to my inner sweatshirt to get in the pockets. Upper 50s, nah, still isn't that bad. All right, anything at all. 3 seconds, 2, 1, 0. Okay, there's barely any change, which is fine. We kind of want to see that as barely any change. All right, I'm going to go ahead and reboot one of the cameras. So I'm actually going to check to see where Cassiopeia is. Um, it's the lights. Yeah, I can't see a thing. So here's what we're going to do. We're going to cameras. Let's see if this works. Hope this works. Give me my. What's it doing? 50 milliseconds. I'm going to do LX mode. Give me a 4-second exposure. I need to see something. Okay, we're going to do this. I'm going to kill my light. So now I am back to being kind of dark. There we go. now it's kind of working. All right. So, uh, that's my house. That's my roof line. You can see the Orion. You can see Orion right over here. You can see the Orion Nebula right over here. So if I do this, yeah, I'm not. I'm just below here. Okay, it's not quite centered. It's pretty close. Ain't perfect. It's close. So for the 4-second exposure, we can see Orion here. And if I bump this thing up to, let's just do an 15 seconds, why not? I don't care about getting that much detail. I really don't. Let's see what happens. I want a 15-second exposure. I just want to see what I can see with 15 seconds. No, we don't want 15 seconds. We definitely don't want 15 seconds. This is like it. The moon is lighting everything up. That could actually be why Orion Nebula is so bright, is because it's close to the moon and the moon is lighting everything up. It's, yeah, it's pretty close. That actually, that's a really good explanation why. So the moon is actually, if I look at Orion, there's Sirius, there's Orion. So the moon is located right off over here. So it's not only is it getting lower in the sky, but it's in the same direction as the moon. Okay, well, in that case, we have to go to where we want to go. We're going to go look at this thing right there. So we want to look at CAF. So go menu. I'm going to do slew target. Sync. Sync to target. Yes. Enter. Enter. Okay, so we're synced to M42, which is good. We do menu. We're going to do select and slew. Go stars. Name stars. Now I got to scroll down. This is just by numbers. I can't type in anything. CAPH, CAF. Right? Yeah, well, CAF. Now I could just go directly to it, but what's the fun in that, right? Okay. So let's see if we can see something just right through here. All right. That's definitely not going to win any awards. Okay. Oh, no. Oh, no. Oh, no. Oh, we're not going to see any nova today. It is too low in the sky. I guess if we had done this 2 hours ago, it would have been a bit higher. Oh, man, no wonder. Yeah, Cassiopeia is way too low. Way too low. I am so sorry. No nova today. Oh, man. I mean, it would be like right here. There's calf right there, so yeah. So we'd be looking right about here. So one, it's probably going to be lost in light pollution from the north. I am down here in Burleson, so everything north is just one big light dome. Um, yeah, so that's where we're at. Okay, so well, that sucks. I was really hoping to see that nova. Um, Maybe one of the club members tomorrow night will get a picture of it. Yeah, just looking at the moon, it's washing everything out. We may have to go up to, hey, maybe if someone is up at Star Ranch or at Thompson tonight, and if you're listening in or not, uh, maybe someone's gonna be able to capture the nova there. Maybe they already did. I don't know. We'll see. We'll see tomorrow. In the meantime, anybody got any suggestions on other targets? Because Nova ain't it. What else can we do? I'm thinking of something. Uh, yeah, I'm thinking of something else. I don't know what. Meze object should do. Maybe get a cluster. Maybe there's a nice big globular. So we're past the Meze marathon. I mean, I wouldn't want to do Meze marathon here with the moon and in the city. We're not gonna. It won't be a fun time. M31. Okay, what's M31? No, M31 is way too. Oh, it's right at the horizon. Man, nuts to that. Not gonna do that. I'm gonna do something up high, 77 degrees. What is M44? M44 is open cluster. Yeah, we've done those. We did that last time. M45, another open cluster. I want to get a globular. M46, M47, open clusters all through the Milky Way. M49 is an elliptical. 50 is a M51. Where's M51? So here's what I'm doing. Let's just do this. So I'm going down the Messier list. Toward the north, M51 is not going to be a fun target. That is going to be the M52 is open cluster. A globular M53. Let's do that. Let's do M53. Back. And menu. Oh, no, back. Select and slew. We're going to go deep sky. We're going to Messier. M52, M53. 5, 3. Not the greatest of sounds. Not the worst. You hear a chunk, 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 chunk. That's never good. Yeah, that was a bad sound. I have no idea why I made that sound. That's just not a good sound. All right. Okay, so that was less than fun. Let's see what's going on. Don't see any cable wrapping. Yeah, I don't know. That's just not a good sound. Hmm. This is not a good sound at all. So, yeah, yeah oh boy. So we're going to do. What's going on? Yeah. I don't know. Not a good sound. Okay. Oh man. You know, stuff like this happens. Uh. Oh man. Okay. All right. So now I have to. I don't know what the situation is, which means that I have to actually. Um. Man. All right. Let's think about this. What could be the issue? It could be. Oh, well, let's do this. What is going on with this? I wonder if it's. That's good. Okay, so what I'm doing is I'm actually checking the clutches. Let's see. Okay, the clutch might have been a little bit tight. The balance is okay. So I'm going to have to do this. I may have to do a realignment. Huh. So now it says unknown position, which is never a good sign. So we'll have to do the alignment. I'm going to do, let's just do a 2-star alignment. Serious. Okay. Not a good sign. It's not a good sound at all. Okay. I get stuck. Yeah, it's not a good sign. Okay. Well, I'm hoping we don't have to, I can fix this. We don't have to call it a night. Oh, whoa. That would do it. What's going on? Huh, okay. Well, my balance is off. What happened to my balance? That would do it. Okay. Yeah. Um, all right, I want to do this. So, I'm going to switch cameras. This is something really, really important. Yeah, this is something super, super important. Okay. I'm doing something with this mount, which probably isn't what it was designed for. Actually, I know it's not what it was designed for. I have 2 telescopes on it. They need to be balanced in a particular way. They're not. And so when the telescope is in one position, it balances just fine. When it's in a different position, it's no longer balanced. In this position, the way it is right now, hoping you can see what's going on. This position, do the clutch. It is really poorly balanced. There's so much weight now this side of the mount that it can't possibly hold everything up. It's just, it's bad. Nothing is slipped. Right? Oh, oh boy. Oh, yeah, something slipped. Yeah, someone seriously slipped. I have no idea how. Oh, wow. Okay, well, on the plus side, um, the plus side, y'all didn't see several $1,000s worth of equipment hit the ground very hard, which could have happened. Wow. Okay, I'm not sure how this happened, but it, the the plate worked itself loose. I don't know how. I had it tightened up as much as I could. The plate actually worked itself loose, and it moved and moved and moved and moved, and it almost fell out. Okay, so the fix for it is just a fix. So that's pretty scary. That would have gotten probably a bunch of views. Much crying from me. Yeah, that I have no idea how this loosened up. It's, yeah, this is loose. I have to see that. That's not a good sign. Okay, a little bit more. Well, that's I have to jiggle it, make sure it's not going to come loose again. Wow, that's that was really bad. I don't know how that happened because I had it tightened up ahead of time. I wonder if I need to make a call to Ioptron and see what to do, or if I need to upgrade. Um, can't really get bigger knobs because you can't really get my fingers in here. Wow. I can think of a couple of less than choice words at this moment. That would have been super bad. Uh, that would have been really bad. Okay, so yeah, I don't even have words right now. So happy nothing happened, but I've got two details. I didn't even realize why my balance was off so much. That could have been if I had left that all night. Let's say if I was doing imaging, I had just left this all night, slowly worked itself loose. I could have come in the morning and had broken cameras and telescopes just all over the floor because this is on concrete. This is the surrounded by my pool, smashed into the ground. I would have been done. That's it. Just done. Okay, better. It's tightened up more. Yeah, no, I got no idea how it loosened itself up like that. I don't have a clue, but it's better now. That's a scary moment, and I think from now on I'm gonna have to watch it and make sure that this doesn't happen again. So this is the first issue I've had with this mount. This is the very first issue I've had with this mount. But this is a serious issue. You do not want your telescopes just falling out. Yeah, I I'm kind of at a loss for words. But has anyone else had anything like this happen before? Put in the chat. Let me know. That's just what's this thing? Apparently, just no. No. Okay. I'm gonna do menu. I'm gonna. Uh, I'm just kind of brain farting right here. So I am going to. I can see Sirius. I'm going to try to see if it's still aligned just by going to Sirius. I don't know if it is or not. Sirius. Here we go. Not pointed. So it's off again. All right. Well, there we are. Oh shoot. Y'all can't see what's going on. I am terribly sorry about that. I am so sorry. You didn't see me doing all that stuff. Uh, okay, so ah, that is not pointed at Sirius. That's pointed down at the ground. I'm gonna have to pace it. Today could have been a very, very bad day. Today could have been just a horrible, absolutely no good day. You ever seen a grown man cry? You would have seen a grown man cry. So the alignment is now totally, totally just gone. Fix that. Just totally, totally off. Okay, so that would have been as bad. Um, yeah, that would have been just as bad as it could possibly get. Uh, had that not just started grinding and had I not checked what was going on, um, both telescopes would have fallen off the mount and smashed into the ground. Um, it probably would have hit my teleview first, which would have broken the glass. It would have hit the camera, destroyed the camera. Um, if the carbon scope had fallen, it would have destroyed that one as well. Anyway, let's go on. Hey, what else can you do, right? All right, so here we're looking at Sirius. Sirius is there. Okay, good enough. What about here? That's Sirius blown away out over here. Um, let's get let's get in the field of view here. We're gonna do frame and focus. We have to get Sirius in the middle. Um, and let's get this out. Sirius is right there. Cool. So we're gonna go Sirius down. Wrong direction. Oh, okay. That's pretty close, but let's get it better. Oh, man. That's pretty close. Now we have to go back to here, and we're gonna switch cameras. We're gonna go to here. We're gonna pick 50 milliseconds. No, we're gonna pick. Okay, that's pretty good. All right, let's center it out. That's where we want it. So we're gonna go slow. Okay, too far. Down. Over. Even slower than that. This way. Cool. This way. All right. You know what? This is going to be good enough. So back, menu, sync to target. Yeah. All right. We're synced successfully on Sirius. Sirius is close enough for us. It's close enough. Okay. So yeah, that was scary. That was scary, but we're gonna go on. M53 menu selected slew deep sky object Messier 53. All right. I just have to be super super careful with this thing now because there's just absolutely no way I can let that happen. I don't know. I may have to do something, upgrade the saddle. I don't know. thought I had that cranked down. I'm going to go test it again now. It's cranked down as much as it'll go. I'm not, yeah, unable to do it anymore. All right, switch to here. Oh, all right. So we're looking at Sirius. I just had it centered. Um, M53. We're going to go to, let's do a 4-second exposure. So we can see, if anything, what do we got? Nothing. Okay. Next. 15-second exposure. Oh, 8-bit. I don't care right this moment. I just want to see if anything is in there. Here, let's do this. And imaging, we're going to do, I want not 60 seconds. We're going to go with 30-second exposure. I just want to see what's there. 30-second exposure for that. What do we got here? Nothing. Gain is way up. 15-second exposure. I'm still not seeing anything at all. 30 seconds. You know what? Switch cameras. Go with this one. Oh, and I have to turn off the HD. Close. I have to clear. Modify calibration. Yeah, that's fine. I don't see anything. Yeah, I gotta stop it. Stop. Loop. Leave it at that. See what we got here. No, wrong button. That was the wrong button. I don't have anything. Why don't I have anything? What do we have here? 30 seconds. All right. Let's let the thing finish. Why don't I see anything? Oh. Because that camera's not working yet. No, wait, yeah, it is. 15 milliseconds. All right, 4-second exposure. What part of the sky are we looking at? We're looking up in the northwest. Okay, what do we see? I don't see a globular. We should be seeing, oh, wait, there it is. Should be seeing it right through here. Let's get 8-second. Get a little bit of gain. This is where it should be. Okay, so we're looking at this general area right over here. Okay, what do we got here? Oh, there it is. That's way up high. It's no wonder we're not getting anything. This is the part of the sky that we're imaging on the other camera, and there's nothing there. We want that guy. M53. Yeah, so we're way off. So here's the globular, M53. How are we gonna fix it? We're gonna hate ourselves. Okay. I'm gonna hate myself. All right, I have to do this. I'm gonna hate myself so much, but that's okay. Bump this way up in 10-second exposures. All right, just start looping. Anything? No, not loop. Let's go. Which direction? So the image is down, so I need to go this way. Okay, let's take the next image, see if we can get this thing centered out. I'm pretty sure I went the wrong direction. I'm pretty sure I went the wrong direction. I'm pretty sure I went the wrong direction. Sean's offered me to come down to Granbury. Grandview is actually it's actually darker than Granbury. Last week we were down in Grandview on family land, so I have the advantage of there being nobody out there. That was dumb. So there's nobody down there. They've got 30 acres, and it's really quiet. Unlike here, uh, I don't know what that sound is. I think someone's beating a rug. I don't know if you. Yeah, someone's beating a rug back there. uh, let's see, what direction are we going in? Pretty sure I went the wrong direction. Uh, yeah, it's quiet. I have good internet access, and the skies are pretty dark. I don't have to worry about neighbors. I don't have to worry about street lights at all. There's just nothing out there. Next, come on, give me a good image. There we go. I guess I was going in the right direction. Yeah, if we go from here, that one, that one, it's going in the right direction. Yes, we'll find out. I'm gonna do 1, 2, 3, 4, 5. Get another capture. I could probably go with a faster exposure instead of 10 seconds, do 5 seconds or something. But oh man, it kind of just hits you really hard when you realize you did something dumb like that, man. I would say it happens to all of us, but no, it really doesn't, does it? I don't think I've ever heard of anyone else's scope falling off the mount. Oy. It did. It was a couple of inches from falling off the mount. It worked itself. It worked just about 3 inches off. The my base plate worked just about 3 inches off, and then there's about 2 inches left. I think if I had gone another inch, it would have been just really bad. Okay, so we go 1, 2, 3, 4, 5. This I'm gonna do a 5 second exposure. I'll just do it faster. So again, the scope is wide field, but I don't think the light pollution filter on here is doing terribly well, and we just have bright skies. It's not pointed away from the moon; it's just bright skies. And this particular light pollution filter, not LDAP, LDAF, it's just not it's not cutting it now. So this should be right about here. Yeah, I can go a little bit more. 1, 2, 3. And what I need to do is decide which direction. Let's go down. 1, 2, 3, 4, 5. Start capture. So what I want to see it right about here. If it's not here, if it's way over here, I know I hit the wrong button. Oh, it'd be the right button. Right button. Right button. Nope. Wrong direction. Now the question is which one did I hit? I think I did this one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. More, so I'm holding the button that I hit. I suppose it would be nice if yeah, if I had plate solving and everything automated, that'd be just fantastic, wouldn't it? But it's also more stuff to break. I didn't mean to say that. I swear I'm gonna have nightmares about this. Is that it? Which way to go? Okay, so wrong direction, right? Wrong direction. On the right level. Come on. What does that guy do? Let's switch to. No, not quick capture. I don't want that. I don't want to switch cameras. So I'm hoping. Okay, fine. Oh, geez. Now I have a crash. That's always a good sign, isn't it? Yeah. Oh, yeah, it's okay. Um, just wait. There we go. Oh, it is in the center. All right. Cool. So I can come here. That's fine. Absolutely fine. Cameras, we're going to switch back to this one. And we're going to take fine. Thank you, Sharp Cap, for letting me know. We're going to go with a 30-second exposure. Why? Because we can. That changed 24. That changed 24. Okay, we're going to start cooling again. Oh boy. All right. Yeah, 7 people stuck around to almost 11 o'clock. I think what we're going to do is do some more imaging of this and then call tonight. I've that kind of did me in right there. Um, ooh-wee. All right, so we got 2 stars over here. So let's match them up. 2 stars, 3 stars. Should be seeing something, right? No, there we go. I see what we. I see where we're at. Okay, so we got. I see what we're doing. We should be looking at it right over here, and I think we can right there. There it is. So what we have to do, it's gain should be fine. We need longer. Let's do a 60-second exposure. But yeah, I think we're looking at it right in the middle. It's just hard to see. I think if I dump the gain a little bit higher, but let's see what happens. We'll do a with the 60-second exposure because here I think these are the 2 stars we're looking at. That's it right there. It's a nice little globular. Oh, yeah, just scary. Just scary. At least I'm hoping this is gonna pop up there. If not, then and I'll have to do a sync on it. There it is. Oh man, that's just faint. That is just very very faint. Um, I'm gonna bump up the gain a little bit more, and we're gonna have to go for a longer exposure. We're gonna get just full 2 minutes. And I'm gonna sync. So menu, sync to target, enter, enter. Yeah, we're synced now. So it'll make it easier to find stuff. Give your okay. It's getting colder. Wind's starting to pick up a little bit. It's down in the lower 50s. Um, yeah, it's just oh boy, it's kind of cold. Just barely there. So we'll give another minute or so to finish that up. Um, all right, see what happens. Cooler is on. That's an advantage. We just barely see that globular. I think if the skies were darker, it might pop out a little bit more with a longer exposure. But it's a fairly dim one. Let's see what it should look like. M53 globular. Hello. And it crashed. It actually crashed. Not going for me tonight, is it? I saw the moon. It's the nebula. Nearly trashed both telescopes and cameras. Actually, there are three telescopes if you count the guide scope. So, three cameras, four cameras. Oh. All right, there we go. Now we can see the little globular. So it is it's not too bad. It's pretty faint. It took a 2-minute exposure and bumping the gain way up, but we can at least see it. Let's zoom in. So I like this camera. This camera is actually pretty nice. Uh, but we're not. Yeah, we're trailing. We got some star trails, and that is because I'm not guiding. I haven't started guiding yet. So, but there we go. That's a nice little globular. You can definitely make out the core, surrounding stars, the outer layers, oh, excuse me, outer edges. Um, let's see what else we got. Oh, have to do Starry Night again. All right, let's bring up Starry Night. What just happened? Oh no. Oh no. No. Um. Uh. Well, that's interesting. All right. What just happened? Uh. 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 Yeah. So. Try this again. Okay. Well, I just lost my D drive, which is never a good sign. Um. Yeah. So I just lost my D drive. Not my D drive. My. Okay. So I've got. I can't even rescan disks. Okay, so that's where I'm at. Okay, I can do imaging, um, but I can't do Starry Night. I can't save anything because it's not going to save to my drive. I lost a hard drive on the laptop. I don't know why. A reboot will probably fix it, but I can't even rescan. Um, not to the GUI at least. Today is not my night. See, I just said something, and then all of a sudden I lost everything. Um, it's just, oh boy. So yeah, we have to do stuff like this. Um, okay. Uh, I lost that disc. Yeah, I'm gonna have to reboot. So okay, all right. That's not a good sign. Um, how about Starry Night? Starry Night 7. Maybe this will work. I didn't put it on that drive too. I hope I didn't. Okay, so at least this one's coming up. So yeah, essentially, one of my hard drives just died. Um, it's an old spinny drive, but I wasn't doing anything with it other than writing to it, and all of a sudden it just stopped working. I, so yeah, um, man, it's been a fun night, hasn't it? Just all sorts of stuff is going wrong. All right, yeah, I kind of have words right now. It's not a great night. I had hoped to actually do one more thing before we shut down today, but I think we're gonna. Yeah, I'm gonna look at Starry Night. Starry Night 7. Okay, look at Messier objects. What can we see? Uh, Leo triplet, M65. Where is it? Where are we looking? That's not too bad. M65. Let's zoom in on it. M65. Let's just look at M65. I want to see if I can get anything. I'd like to get Bodes, but I think Bodes is going to be too low in the sky. Let's find out. M81, M82. No, northeast. You know what? Let's do M81 and M82. I'm actually interested. I want to see if I can pick it up. M81. 81. Just as long as it doesn't grind again like that. Jeez. That is a horrible thing to sound. Oh, come on. Don't be. Oh, good. I thought I was going to hit the meridian. It's probably pretty close to the meridian. Um, all right, let's do. Hey, there we go. That's like a galaxy right there. It does look like a galaxy. All right, let's do. Uh, ugh, I just feel bad. I just feel bad. I don't know if that's in the field of view. We'll find out. So let's go with a. I'm going to go 10-second exposure. Um, let's just see what we can see. So this is M81, M82. What we're going for. So this is Cigar Galaxy and Bode's Galaxy, or Bode's Nebula. One is a spiral. Actually, they're both spirals. One is like a not quite face on. The other one is edge on. So I call it the cigar because it looks like a oh, excuse me, looks like a cigar. All right, what do we got? What do we got? What do we got? Hey, there we go. We got something. So here's Bode's Galaxy. So we're not going to get both in the same field of view with the other one. So this is one galaxy, and this is the other galaxy. So this is the cigar. Sorry, this is Bode's Nebula, and this is the cigar. So we're able to pull them out. We're actually able to see some definition right there. Uh, so this is not the greatest of things. Let's see how this is doing. We're guiding. No, we're not. We're not guiding. We need a clear calibration because we're guiding on a totally different part of the sky. That, and let's loop. Go ahead. You do your thing. So jump over to here because we ain't got nothing. I'm gonna go to this guy and let's do 8 seconds. I do not care. 8 seconds, 100% zoom. I just want to see what part of the sky are we looking at? Looking up. Can we see where this is? It should be somewhere in here. We're not seeing it too well. So where are we looking? We are looking in the east to southeast. No, we're not. Here we go. We're looking up in the northeast. Northeast, almost to the north. Almost due north right now. And let's look at constellations. So labels, I want to see. Do that. I want to do Messier objects, and I want to do. Where are they? Constellations. Okay. Ursa Major. Here we go. Ursa Major pointed down towards Polaris right there. So Big Dipper is upside down. Hey, we could hit the pinwheel. We'll try that too, the pinwheel. That's not just because it's cold. All right, are we tracking yet? Are we guiding? Nope, not yet. Almost there. Almost. This is how we do guiding. Just wait, wait. It's still calibrating, still trying to figure out what it's going to do. But if we want to get a decent image, we have to do guiding. So, fun, fun, fun. I don't know about y'all, but that just scared the pants off me. That was that's something I gotta watch out for because it was something completely unexpected. Um, yeah, nudging to the south, moving that star right back to where it should be. I can't really see it that well. Here we go. Now it's guiding. Now it's locked onto it. All right. Guiding. Let's go back here. Leave that alone. That be it. Maybe it's the right position. I'm gonna switch cameras and do a switch modes. Get the cooler on. And let's do 60 seconds. So we can see with 60 seconds. And auto. I there's gotta be a way to force it just to always use a particular way of doing it. Is save as. Call it that. I can't even do that. That's the profile one. I guess. I need to play with it some. All right, we're at 20 seconds left in this exposure. Hopefully there'll be something pretty in here. You can see M81. Then we can jump to M82. I don't typically shoot galaxies from the city, but we'll see what we can get. I'm just as sure if I can get it. Hey, there we go. It's not in the center. And it's a little bit streaked out. What does PhD say? PhD. Yeah, I was still trying to get its feet in. Um, yeah, it needs a lot more work. It needs a lot longer exposures. I think like a 5-minute exposure should get it. I think it's the issue we're going to have with all these galaxies is the longer the exposure I do, the worse it's going to be. And in terms of light pollution, these are dark sky targets. They're dim. Um, I'm just not going to be able to image galaxies very well, I think, here from the city. Um, Especially pointed up north where the light pollution dome is. This is really something really for dark sky sight. So even down in Grandview, I'd be kind of hard pressed because it is up towards north. This is really a target that's really good for Thompson or for Star Ranch, for our club's two dark sky sites. I don't think I'm going to be able to get much here. And the temperature just dropped. In the last couple of minutes, it's probably dropped down 5 degrees. And a little bit of wind, but the temperature just plummeted. It's it's not fun right now. I'm I'm kind of tired, so I'm gonna go ahead and call it quits. That mount, the plate slipping down like that. I can see now why it did it. It was loose enough. Just moving it vibrates it and just causes it to shimmy down. I'm not sure how we can fix it. Uh, Other than just cranking it down when I tighten it. I don't know. I'll probably end up calling Ioptron and saying, "Hey, here's my problem," and see what they say. Unfortunately, it may take 6 months to get any fix. So I don't know. I'll figure something out. There's actually there's a bolt that I had to remove, and that's kind of a safety to keep this from happening. I may have to figure out a way just to put that back on. Yeah. So there we are. We're gonna get one more image out of it and see what we can see with Bode's Galaxy, but I don't think it's going to be any decent now. Um, oh, yeah, I'm kind of beat. What? It's cold, tired, and with what just happened with that, it's not fun. So we can see a little bit of movement, so that's good. Um, if you like what we do, you can go ahead and hit the like and subscribe button, um, and let us know in the comments in the chat what you think. I will continue to do these for as long as necessary, as long as it's still fun. I would really like to do one of these from one of our dark sky sites. Unfortunately, um, power wise, from one of them, it's feasible. Internet wise, it is not yet feasible. Thompson has internet access, however, it is metered access, and I would burn through their month in about an hour or so of streaming. It's just totally not feasible. And the other site has just really bad cell phone reception. So even if I had a hotspot, I don't think it'd be feasible. I have looked at Starlink. Um, I did get my email on saying, "Hey, you want to go ahead and sign up for it?" And the equipment is $500, but it's really cool. It is a phased array antenna, and then it's $100 a month. I really can't justify that uh, on top of my current internet connection. And it's not like I could get rid of my internet connection, my landline, and then just go to Starlink. Um, because if I pack it up and go, now there's no more internet connection at home. So plus we just got fiber to the neighborhood, so we'll be getting fiber hopefully in a couple of weeks to a month. They're just now finishing that up. But honestly, Starlink would be something that would be feasible, especially if you're a remote astronomer and you're constantly on the road. Starlink looks like it's the way to go. You could have it in your RV, you pull it out, or you just have it mounted to the roof of your RV or your trailer, uh, and then you just connect with Wi-Fi from your equipment, and you have internet access wherever you go. It's pretty fast. Could be feasible. Could be an option. It's just not really an option for me at this time. But in the future, especially if the price goes down, if the antenna gets smaller, it might be worth it. Go out to Big Bend and broadcast live from Big Bend would be really, really nice. I have been out there a couple times. The skies are very, very, very dark. It, it was so dark that I did not know what I was looking at. There were just so many stars. It's like you just get lost. The constellations kind of fade into the background. Um, you really have to focus on where you are, where you're facing, and what stars you're looking at. Because it is just so many. And this is during the summer, so it's the summer Milky Way. So that's an option for the future. I'm not gonna worry about it right now. Um, I don't know when the next one is going to be yet. We have some bad weather coming up. This not this week, I believe it's the end of this week and into next week. It's also going to be a full moon next weekend, so there's really nothing to see back then, or during a full moon anyway. So I'm going to probably spend some time and reorganize my stuff. I will probably take apart at least the saddle and figure out what's going on to see why there's slippage. I have to figure out some way to really either crank it down more, use like a ratchet or something, because I definitely do not want this to happen again. I'm wondering if this happened previously, and that's what caused the that kind of grinding sound when it was grossly out of balance. Um, so it can not only drop the the scopes down to the ground, but it can also break your mount because now it's horribly out of balance and those gears are grinding. They're trying to move it and they just can't. Mounts like this, they have to be balanced. They just have to. It can be slightly out of balance and the gears can handle it, but as gross as the balance was off this time, it's just not feasible. Just not doable. So my wife wants me to come home, come inside and her up. Uh, she's got cold feet. She likes to stick in the back of my knees. Uh, but yeah, we're gonna go ahead and pack up. Oh, thank you, but I'm about to pack up. She brought me some tea. Uh, yeah, I'm gonna warm up and I'm gonna pack up. So, oh boy, I want to thank everyone for joining us this evening. I can't say it's been fun, but it has been interesting. It's been a scary, scary night. We did some good moon viewing. Didn't get to see the nova. Maybe someone will be able to do some imaging. I think I'm just going to pack everything up tonight and put it inside the house and just not worry about it. Oh boy. So again, thank you everyone, and have a good night. Again, I'm Chris Moynitsky from the Fort Worth Astronomical Society. Oh boy.